Welcome back. We're going to be jumping straight into the AWS Management Console for some hands-on EBS volume experience. So let's jump straight into EC2 because remember, EBS is a service specific to EC2, and so it is not a separate storage service. So we're going to have to jump right into the EC2 dashboard. And let's just go into running instances. Obviously, we have no running instances. The first thing I want to show you guys is how to create, or how EBS volumes are actually created with an instance. So again, you can create, and I'm going to be showing you how to create independent volumes, just complete independently of any EC2 instance, and then later attach it to a running EC2 instance. But first, let's see how this happens by default. So let's just go into launch instances. And every time we come into here, we discover something new in one of these steps. In this case, we're just going to be creating our regular instance. And now if we let's jump into review on launch, we can see that down here in storage, we actually have an EBS volume that comes attached with our EC2 instance, and this comes attached as the root device, and it is that of type GP2. If you remember, we learned about the different volume types. We had the GP2 and GP3. We had IO1, IO2. We had ST1, SC1. And these would depend on whether or not you wanted SSD or HDD, so on and so forth. So we said that, the GP2 is what's recommended for most workloads. And so that's what comes by default. And it comes with a size of 8 GB. And it's by default, it's called /dev/xvda. And we're going to see that when we go into the instance and also when we go into volumes. And it comes with its snapshot. And by default, it's not encrypted, and it will delete on termination. This means that if you save anything into basically on your instance, will be saved. Everything will be saved to this root device, to this root EBS device. And if you terminate your instance, it will be deleted. The volume will delete with the instance type. So we want to change that. So we just go into step number 4, add storage, and let's modify what's going on here. So we can actually change the volume type. So we can pick a GP3, we can pick an IO1 or an IO2. We can also pick a magnetic type. We're not going to be covering these, but by default, the IOPS that comes with it is set to a baseline of, or a minimum of 100, because I'm going to be showing you these in more detail when we create independent volume types. But essentially, there's a baseline of 3 IOPS per GIB with a minimum of 100 IOPS. And these storage types or these volumes are burstable to 3000 IOPS. So if you do not want your volume to be deleted on the termination of your EC2 instance, you can go ahead and uncheck this box here. And if you want to encrypt your volume type by default, you can go ahead and select from here which key you want to use, and that involves KMS, which is a whole nother AWS service that we'll be covering later. But essentially, this is where you can do that. And you can actually add new volumes to your EC2 instance while launching it. So at this point, during launch, and they, you can assign them a range, from a range of names, everything from /dev/sdb all the way to /dev/sdf. All of these are available device names. And then, you can change the gigabytes. You can, based on the gigabytes, the IOPS will change. So now it's 300 because, there's a baseline of 3 IOPS per gigabyte. So 100 times 3 would be 300. So let's go ahead and set this at 100 gigabytes. Why not? And we'll just keep it at GP2. Now, one thing we do want to make sure of is let's go into configure instance, and let's just make sure we specify specify a specific region, a specific availability zone within our region. Let's specify it to US East 2A, just so it's easy to remember, A. And the reason for that is because we're going to be attaching different volume types to different devices or different instances. And remember, volumes are specific to a particular availability zone. And I'll show you how to transfer between availability zones. By taking snapshots and then creating volumes from snapshots. But for this video, we're not going to be working between availability zones. So we do want to make sure that all the volumes we create, as well as the instances, belong to the same availability zone, so that we can, pass or swap volumes between different instances. So with that, I think that's enough. Let's go ahead and let's actually have the root volume delete by default. But this attached volume we won't delete. Actually, I won't even. So you can see that we can attach it here, but let's go ahead and not attach a volume here, and instead I'll show you how to attach it after the instance has been created. But you can now see how to add new volumes while launching an instance. So let's go ahead and review, launch. I do acknowledge, and we launch. So we should have a running instance soon. It might take some time. There we go. We have a running instance. Let's just go ahead and call this first. Okay. Now, if we click on this instance and we go into storage, we can see that the root device is an EBS volume, and the specifics are down here. So it is attached. This is its size, and it is not encrypted, and it will be deleted on termination. And this is a device name. And then when we click on this, we'll jump right into Elastic Block Store volumes. So we could have just clicked on here right away. And here we can see all the volumes we have. Right now we have a single volume. Before we created the instance, we had none. And if we delete that instance, we will have none again. Because why? This is set to delete on termination of the instance. So it will not persist. As long as the instance is running, it will run. And you can view all the details down here. But basically, what we want to do now is let's go into our running instances. Let's go into first. Let's connect. And let me show you how you can see your the different devices volumes that are attached to your EC2 instance. So this is going to require some Linux administration, but don't be frightened. It's pretty straightforward. If you know what ls does, right? It basically shows you, like, let's go back one folder, ls. It shows you the folders that are in the current directory. So let's just go back into the directory we were in. Now, ls bulk, like this, lsblk, will give you the devices that are attached to your device. So we do have our root volume, which is attached, and that's given the name xvda. Now, if we go into, let's go into volumes in a separate tab. And the name of this volume is given down here in attachment information. So we can see that it's attached to the instance by this ID or by this name. We gave it the name first, and it's attached as /dev/xvda, and it is attached. So if we go back into here, we can confirm that xvda. This command removes dev/ by default. So this is actually /dev/xvda, but it removes that. And it's mounted on the root folder. So basically everything that's within this file system that we are in is saved to that volume type, okay? And we can view some specific information on how this volume type has been formatted by using, there are a couple of commands we can use. So we can do sudo file -s and then the name of the device name. And so here we can see that this is, all the details. If you know anything about Linux administration stuff, you can basically read that. And actually what we want to see is xvda1, and we can see that it is formatted as an XFS file system, and some additional information on that. Or we can do sudo, again, lsblk-f, and this gives us information on all the attached devices. So it is a, file system type is XFS. So basically we have one instance, and that instance has one EBS volume attached to it, and that is the root EBS volume that is attached or created while you're launching the EC2 instance in the first place. Now, we want to create a new volume, okay? A new volume independent of any instance. So you come into volumes under Elastic Block Store, you click on create volume, and here we go. You can select any of the types we discussed: general purpose SSD or GP2, general purpose SSD, GP3, provisioned IOPS SSD, so IO1 or IO2, cold HDD, which is SC1, or throughput optimized HDD, which is ST1, or the magnetic one, which we're not covering. And then based on that, you can specify the size. And again, this, go ahead and read these notes. These are useful. So basically, this volume type comes with a minimum of 100 IOPS, and then after that, for every GIB, you get 3 additional IOPS. So for example, if we had just 8, the minimum is 100. Even if we have 10 times 3 should be 30, but the minimum is 100. It doesn't change. 20 times 30 should be 60, but the minimum is 100, so it stays 100. But as soon as we pass, like let's say that to 200 times 3 would be 600, so this will change to 600, and so on and so forth. So, and then these will be burstable up to 3000. Obviously, if you have a volume type that is, that has more IOPS, than 3000, then it will not be burstable. But if it's below 3000, then it will have the potential to burst up to 3000. And the details of those will depend on, the credits that you earn. And the credits you earn will also depend on the size and other characteristics of the volume type, etc. So for all of that, definitely refer to the documentation. No need to, pack all of that into a video like this. And then again, the throughput, we said that the GP2 devices or the GP2 volume types are not, their dominant feature is IOPS and not throughput, because they're solid state drives. So if we were to select, for example, a hard disk drive, let's select like SC1, then we get the throughput, and the baseline is 12 megabytes per second per TIB. So again, this will all depend on your volume type, and so definitely be sensitive to that. This is good for most cases, GP2, but again, it's going to depend on your use case. Now, something that's very important is the availability zone, and good thing that we know the availability zone of our instance, so we don't have to go and check. But essentially, if we were to create this volume type as a within the US East 2B availability zone, we would not be able to attach it directly to our instance. We would have to create another one within this availability zone here. So definitely watch out for availability zones. And let's not encrypt this volume, but we can. So this is where you would do it. and then you would select your master key and that kind of stuff. But we're not going to be doing that. Let's not go with 500. Let's just do 100, or, you know, we don't need 100. Let's just do 10. And let's go ahead and create this volume. Let's close. So it's being created. It's in the creating state. Our other volume type is in use because it's attached. And the details of that are here, right? It's attached to a currently running instance. It doesn't even have to be running, but it's currently attached to an instance. And we saw that here. Now let's go ahead and refresh this. There we go. This volume is now available, and we can now attach it. And how we do that is, let's name this. So independent. There we go. Okay. It did a name. Okay, there we go. Independent. For independent. And this is, you know, we'll say first, right? Because it's just attached to the first. It's a root device of the it's the root volume of our instance named first. So let's click on this. Actions, attach volume. And from here, we're going to select our first instance. And we can change the name, but, you know, we don't need to. We're just going to call it what they gave it. They gave it to us by default, but there's a range of names all the way up to SDP. You can name it. But note that Linux kernels might rename your device, and they will in our case, right? Because they have been renamed to XVDF, for example, in the case of the root volume device, all the way up to XVDP. So just keep that in mind. If your Linux kernel does that, it won't change here, so it'll still stay the same. So that shouldn't be a problem. And let's go ahead and attach. Now it's being attached. It's already in use. There we go. It is now attached. And if we click on it, we see that it is attached to the first instance, and it's given the name /dev/SDF. Now, if we actually go into the first instance, let's click on this. Here's our first instance, and we click on our instance and we go down into storage. We can now see that we still have our root device, but now we have an additional device of /dev/SDF. Okay. And because this was created independently, obviously it will not delete on termination. And so now when we go into here, let's go ahead and refresh. Now, if we do lsblk, we now see our second device that's been attached. And just like AWS warned us, our Linux kernel did rename it from SDF to XVDF. Okay, so this is the new volume type that we created, that we gave the name of ind2 for independent. Obviously that's a name just within AWS. It's not, you know, it has nothing to do with the actual volume type, so it's not going to show up here, but that is our new device. And you can see that's 10. The size is 10 gigs. And so the one thing you should notice here is that it has no mount point. It has been attached, but it has not been mounted. And in order to mount it, we need to actually format it. So after you attach an Amazon EBS volume to your instance, it is exposed as a block device. And you can format the volume with any file system and then mount it. Now, there is a chance that an EBS volume that's been attached to your instance has a file system, actually, right? That it has been formatted, especially if it's a volume that has been created from a snapshot. It most probably will have a file system, you know, because it doesn't really make sense creating a snapshot of, you know, an EBS volume that has not been formatted, because there's no point, right? There's nothing on there worth snapshotting. So most probably it will have a file system. So before you try to format it, definitely do check. If you do format it and you create a new file system on it, it's okay. It'll just overwrite what's there, but it doesn't hurt to check. So let's go sudo lsblk-f, and we can see that our root volume device has a file system, which is the XFS file system, but our new attached volume neither has a file system nor is mounted, which makes sense because you can't mount a device that doesn't have a file system. So let's go ahead and create a file, or let's go ahead and format the device. So again, we're doing this because the volume is empty and we want to create a file system on that volume so that we can actually attach it. So that, there are probably a lot of different ways to do this, but this is not a Linux administration course, so I'm just gonna give you like a very simple way to do it. We're gonna use the mk or make file system fs command /t, and we're gonna create the /t is type. We're gonna create the XFS type, and we're gonna do that for which device? For xvdf. Now, don't write xvdf because that is not the actual device name. Remember, lsblk removes /dev from the name. So this is actually /dev/xvdf. And if we go ahead and press enter, let's go ahead and check that it worked. And there we go. Our attached volume now has a file system. Now this means that at this point, even if we unattach this volume from this instance, it'll be preserved, right? That volume now has a file system, even if we attach it to another instance. But we want to go further. We want to actually mount this onto our instance, and to do that, we can first, let's go ahead and create. Right now we have no folders. Let's mount it onto a folder within our current directory called data. So let's make a directory called data. Actually, let's put it into our root folder, not our current directory, right? If you do ls, there we go. In the root folder, we have somewhere here. Oh, there we go. We have data we just created. And now we want to mount this file or this volume onto that endpoint or mount point. So we use the command sudo mount, and we're mounting again /dev/xvdf, and we're mounting it to /data, and the slash refers to the root folder in our current file system. So let's go ahead and press enter. And again, we can check sudo lsblk-f. F just gives you the full, the file system, file types for all the attached volumes. There are ways to check for just individual ones, like I showed you. Like for example, we can do what we did. Like we can go sudo file-s /dev/xvdf. And we can see that it has a XFS file system in place. So that's pretty cool. Now we can now see that it's been mounted, lsblk, it's been mounted to /data. This means that anything we save into /data will actually be saved into that volume, into this volume that's been attached to it. And that's really cool, right? So let's go ahead and test that. I guess we can create just a very simple file. Hello world, and we'll just put it into /data/text or hello.txt to a text file. So permission is denied, so let's go into our root user, and then let's do the same thing, echo hello world into /data/hello.txt. And now if we were to go into data, we would see a file here called hello.txt. Now we're actually now within that volume because we're in the data /data folder to which this volume has been mounted. So if we were to print out this file, we see hello world. So now at this point, if we unmount let's go back into our directory, sudo unmount, or umount stands for unmount. There we go. Now lsblk, there we go. We have this volume is no longer mounted. This means that if we now go into here and we detach our volume, let's go ahead and detach it. What we're hoping for is that this volume now will contain that file, the hello.txt file, which will contain the text hello world. And now if we were to attach this to a new volume, to a new instance, we should be able to see that text, even though it's a new instance. So let's actually go ahead and create now. We have our first instance. Let's create a second instance. Select, review and launch, launch. View instances. There we go. We now have a second instance, and this has its own EBS volume. It's being attached, and we can go to it. So let's refresh this. Let's remove the filter. There we go. We have our independent volume that is now available. It is no longer attached to our first instance. And then we have the root volume device for our first instance. And then now we have our second. We have our root volume device for our second instance. Okay. Now, this was populated with data when attached to this instance. Now let's go ahead and attach. Oh, but we made a huge mistake. Again, this is what I was warning you guys against. Look, this is in US-E-2C. And so if we go into instances, the second instance is in US-E-2C. So if we were to try and attach this volume, we won't see the second instance even appear as an option because it's in a different availability zone. It's in US-E-2C, whereas this volume was created in US-E-2A. So basically, we're going to have to terminate that instance and launch a new one. We're going to configure the availability zone to be US-E-2A, and then we're going to review and launch. So it's good to have these kind of mistakes live when recording because it gives you exposure as to how this stuff actually works, right? So let's just call this second, just with big letters, I guess, so we don't, or I guess that's not possible. Okay, anyway, let's just call it sec. And now it should be in the correct availability zone. Now when we go into volumes and refresh, we now have the new volume, which is the root volume device for our second instance, and this time it's in the correct availability zone. So now if we were to attach the independent volume, we can now select between the first and the second. It was originally attached to the first, and that's where we formatted it, and we gave it a file system, and then we put in some data, and now we want to attach it to the second instance. Let's go ahead and attach it. And we can see from here, if we do lsblk, we no longer see that volume type. It has been removed from the first instance. Let's go ahead and close this one. And now let's connect. So let's refresh this. There we go. It's in use now. And it's attached to the second instance type. And so now if we go into the second instance type from here, first of all, we can go into storage. We can see it here. Okay. And then let's go ahead and connect. And then let's go ahead and check the attached devices. There we go. We see this attached device. But now if we do, if we look at the file system of the attached volume, we will see that it is XFS. Unlike the first time we attached it to the first instance, it did not have a file system. And so we had to format it. But now that it's formatted, you know, it persists, right? That's the big advantage of EBS volumes. They persist. So it's formatted, so it can be mounted now. So let's just go ahead and mount it directly. Let's, you know, make the data directory, and then let's mount it. In fact, let's make another directory called, you know, data2, just so, you know, we can see that it's a different name even. And then mount dev xvdf 2/data2. And obviously we made a mistake. There we go. Now we can do lsblk, and it's mounted to /data2. And now the moment of truth, let's go into that folder. And there we go. We see the data. It has persisted. We see hello world, or we see hello.txt. And if we were to print out this file, we would see hello world. And there we go. That is the beauty of EBS volumes. You can now attach this volume to any other instance you want, and you will not have any problems. The data will still be there. And so this adds a whole new level of flexibility to your architecture design. And so essentially that's all you really need to know at this point. Let's go ahead and unmount data2, sudo u mount. Oh, let's just go back in, and then sudo u mount data2. And then now we can go into our instances. Let's go ahead and terminate these instances. Let's terminate them. And then go into our volumes. And now, because we had selected delete on termination, these two will be deleted. But if we hadn't done that, they would still show up here, and then we'd be able to attach them to another instance when we create a new instance. But then, you know, let's also delete these ones as well, just to clean up. Delete volumes. Yes. Okay, the other instances are still shutting down. Okay, so they have been terminated. Let's go back into volumes. They're gone, and now we just have the independent volume, and we can go ahead and delete that volume as well. And there we go. We are back to how everything was. We have no volumes, and we have no running instances. In reality, this could have been merged into the previous video, but I wanted to keep it separate because snapshots do deserve their own attention. And, you know, the last section was introducing quite a bit of new concepts anyway, so I didn't want to mix the two together. But essentially, snapshots are just a continuation of what we were learning in the last video. They just allow you to create backups of the volumes that we were playing with. So essentially, you can back up the data on your Amazon EBS volumes to Amazon S3, and S3 we'll be covering in the next section, by taking point-in-time snapshots. So this is very useful. Keep in mind that Amazon S3 is a low-cost storage service, so the costs will be minimal. compared to having an instance running, for example. Now, snapshots are incremental backups, and incremental backups are sometimes difficult for newcomers to really, understand. So I'm going to be focusing a little bit more on it in the next slide. But essentially, only the blocks on the device that have changed after your most recent snapshot are saved. So every time you take a snapshot of the same volume, you're not saving all the data every single time. If, a part of that volume had previously been saved, it's not saved again, and only the changes are saved. So the purpose of this is that it minimizes the time required to create the snapshot and saves on storage costs by not duplicating data, right? Because if you were to copy out all the data every single time, you'd essentially have a bunch of duplicated data that you're paying storage costs for. Now, Amazon EBS snapshots, essentially each snapshot contains all of the information that is needed to restore your data from the moment the snapshot is taken to a new EBS volume. So all the data that's required to restore it to a new EBS volume. And yes, snapshots can be used to create new EBS volumes. And in fact, you can see this when you're launching when you're launching an EC2 instance. When you go to the storage step on step number 4, and you see the root EBS volume that's being created, you can see that there's a snapshot ID or a reference there. And that's the snapshot from which the root volume is being created. And I'll show you how to do that with your own snapshots as well. Now, charges for snapshots are based on the amount of data stored. So because snapshots are incremental, deleting a snapshot might not reduce the data storage costs. So data referenced exclusively by a snapshot is removed when that snapshot is deleted, but data referenced by other snapshots is preserved. And so you'll have to watch out for that. And you can look up like AWS Billing and Cost Management User Guide or something like that. Just, if it's a very specific topic that you're concerned about. You can share a snapshot across AWS accounts by modifying its access permissions, which is something that's going to come in handy. You can make copies of your own snapshots as well. And so you can also make copies of snapshots that have been shared with you. Now, a snapshot is constrained to the AWS region where it was created. So that's something very important to keep in mind. It is constrained to the region. It is not constrained to the availability zone. So a very good way of, if you do have a snapshot in a particular availability zone and you want to essentially have it in another availability zone, you can create a snapshot of it, and it'll be within the same region, and then you can create a new volume from that snapshot within any availability zone within that region. And after you create a snapshot of an EBS volume, you can use it to create new volumes in the same region, exactly basically what I just said. And you can also copy snapshots across regions, and this makes it possible to use multiple regions for geographical expansion, data center migration, disaster recovery, etc. And yeah, so, there's really not much else to it. Let me just quickly explain to you how the incremental snapshot process works. So essentially, the volume 1 here is shown at 3 points in time. Okay, these are 3 consecutive points in time, 3 different states. So this is the first one, and then after some time this happens, and after some time this happens. And a snapshot is taken of each of these 3, the same volume, but in each of these 3 time periods. In state 1, the volume has 10 gigabytes of data. And because snap A is the first snapshot taken of the volume, the entire 10 gigabytes of data must be copied. Okay, this is copied to S3 like so. And then in state 2, the volume still contains 10 gigabytes of data, but 4 gigabytes have changed. So now when a new snapshot is taken in snap B, only the part that has, only the part that has been changed is added to snap B. And then snap B basically copies and stores the previous or the untouched 6 GB from snap A. And this is done by reference. So it's not copied twice in S3. It's only referenced to here. So this prevents duplication, unnecessary duplication of this data. S3 is already a redundant data storage service. So, it's already dealing with, making sure that data is not erased and duplicated, and that it's duplicated properly in terms of, keeping it secure and preventing data from being lost. So there's no need to duplicate data within that system. And then in state 3, 2 GB of data have been added to the volume for a total of 12 GB. Okay. And this is a feature of EBS that we mentioned earlier that, even while the volume is attached and an instance is live, you can actually add on, or you can change the characteristics of a volume. You can, add on, for example, store it, you can make them, you can enlarge it, you can change the IOPS, the throughput, etc. So snap C needs to copy the 2 GB that were added after snap B was taken, which are the red ones here. They're copied to here. And then snap C references 4 GB of data stored in snap B and 6 GB of data stored in snap A. Okay. So the total storage required for the 3 snapshots is only 16 GB. Whereas if the whole volume would have been copied every single time, it would have been 32 GB, right? So almost half, or actually exactly half of the space is taken. So yeah, there's really not much else to it. It's very neat. It's a very neat system and a very neat concept. And, it just shows how AWS is always trying to help you really truly minimize your costs. They could be overcharging for so many things, but their intention is to make, all of this as easy as possible for the consumer, so that, we do prefer to use AWS over other providers, service providers. So that's pretty much it for EBS snapshots. I'm going to quickly walk you through, the snapshot page on AWS, on the AWS console, but we're not going to dwell too much on it. That, there's really not much else to it. So let's jump right into the console. So here we are in the AWS Management Console. Let's go into EC2, and down under Elastic Block Store, we have snapshots. Now, turns out we do have some snapshots here. They were probably created during, when we were playing around with some of the other services. So that's not a problem. These are just the snapshots that we have available. The only problem here is if you're not aware of this, you might be getting charged on S3. But we shouldn't have exceeded the free tier limits anyway, so that's all right. So from here, you can go ahead and create a snapshot, and you have to select an existing volume or an instance, because when you select an instance, it comes with a root volume attached to it. So I'm not gonna create an instance or a volume, since we already went through that extensively in the last video. But essentially, if there's a volume or an instance with an attached volume, then you would be able to select that volume here, add a quick description, and then create your snapshot. And then once your snapshot has been created, you can create volumes from them. So for example, these snapshots, we're not really sure what's in them. We don't know why they've been created, but it doesn't matter. We can still just go into actions, and we can create a volume directly from this snapshot. Okay. So when we do that, we can specify any volume type you want. We don't have to specify the same volume type of the volume from which the snapshot was created. So this volume is being created from this snapshot, but the snapshot is just the snapshot of the data. And so, we can specify any volume type. We can specify the size. Now, we can specify any volume type, but we can't specify necessarily any size. We can't go lower than the size of the volume from which a snapshot was created naturally, right? because you can't reduce it. It's a snapshot of 8 gigabytes of data. Even if that's empty, you can't go below it. So if we try to go like 7, we're not allowed to, but we can increase it. So we can increase the volume size as compared to the original volume, and then we can select the availability zone. So this is how you can essentially transfer volumes between availability zones. So if you have a volume in US East 2A, but you have an instance in US East 2B, so you want to transfer this or the volume you have over to US East 2B, you can create a snapshot of it like I showed you how, and from there you can create a volume from it, and here select US East 2B, and this time the same volume will be created, the same as the volume from the moment, at the moment that you took your snapshot, will be created in US East 2B, and then from there you can attach it to an instance in US East 2B. And then essentially that's basically it, and then you create your volume. And one last thing is you can copy your snapshots across regions. Okay, so currently we're in the Ohio region. If we were to jump into another region, we would not see these snapshots, but we can copy them into another region, and then that essentially allows us to transfer volumes across regions. So to transfer them across regions, we do it from copy, and to transfer across availability zones, we would do it from creating a new volume from a snapshot that is taken. So that is essentially all there is to this. Also, you can modify permissions. Currently it's private, so you can share, just like we did with the AMIs, you can share snapshots with other accounts, or you can make them private, you can make them public as well, like so. Okay, that's pretty much it for snapshots. These are just quick videos after the main video in which we went through AWS EBS volumes, because these are all just additional features, just like how with every service and every functionality there are a bunch of available features and customization and so on and so forth. So I'm just trying to expose you to as many little options and features as possible, so that you can further delve into any details if you want to. So Amazon EBS Encryption, you can encrypt both the boot and the data volumes of an EC2 instance. And encryption and decryption are handled transparently, so you have nothing to do with it. Amazon takes care of it. And EBS encryption leverages keys from KMS, which we'll be covering later on. So AES-256. And when you create an encrypted EBS volume and attach it to a supported instance type, the following types of data are encrypted: the data at rest inside the volume, all data moving between the volume and the instance, all snapshots created from the volume, all volumes created from those snapshots. So to encrypt unencrypted snapshots, you can't encrypt. So essentially, if you have a volume that wasn't encrypted, and then you create a snapshot from it, and then you want to create a volume from that snapshot, you can't encrypt that volume. But there is a workaround. You can copy that that snapshot, and then create a volume from that snapshot in an encrypted way. So I'm going to show you how to do that. And encryption has a minimal impact on latency, so you shouldn't really hesitate to use it. Snapshots of encrypted volumes will also be encrypted. Okay, so Amazon EBS Encryption is a straightforward encryption solution, and you aren't required to build, maintain, and secure your own key management infrastructure. Amazon EBS Encryption uses AWS Key Management Service, which is AWS KMS, and Customer Master Keys, CMK, when creating encrypted volumes and snapshots. And encryption operations occur on the servers that host EC2 instances, ensuring the security of both data at rest and data in transit between an instance and its attached EBS storage. you can attach both encrypted and unencrypted volumes to an instance simultaneously. So there isn't really much else to it. Again, depending on your particular situation, you might need more information on exactly how this works. In that case, you can consult the Amazon documentation pages. But for the rest of us, let's go ahead and do some quick hands-on with EBS encryption. So here we are again, and we have no volumes, but when we create a volume, we can select to encrypt this volume. Okay, so let's go ahead and create one, and let's just pick the default. Let's refresh. Now from here, we can go into actions and we can create a snapshot. Test snapshot. We can add a tag here if you want. Create snapshot. Close. Now when we go into snapshots, we have this new snapshot that we just created, test. Let's go ahead and delete these. Delete. And so apparently there is an AMI that's using the snapshot. Let's go into AMIs. Let's delete. This is the web server. So this is the AMI that we created. So it's using that volume or that snapshot. It is basically the snapshot for that AMI. So we can't delete it. So we just go ahead and leave it. Let's call it web server. Okay. And this is our test. And when we click on test, down here, we can see that it is encrypted. And so if we were to create a volume from this, it would be encrypted by default. It would be we can't unencrypt it. Okay. Now let's create another volume, and this time let's not have it be encrypted. So let's create an unencrypted volume. By the way, here when we're creating volume, we can just select snapshot from here as well, instead of going into snapshot and creating from there. Let's not encrypt this one. Let's create the volume. And now we have another volume that we just created. So let's call this the first one. First test. First. And this is second. Now let's create a snapshot from this. Test 2, and it's not encrypted. Create snapshot. Close. Let's go into snapshots. Let's click on test. Let's rename this test 2. Let's go ahead and create a volume from this, and we can now encrypt this volume, even though it was unencrypted originally. So test 2 was unencrypted, and it's from this volume here. So we can go directly to the volume, and we can see that this is not encrypted. However, when we go into the snapshot, we can see that when we are creating the volume, we can now encrypt it. Now this is new. Previously you weren't able to do that, and you would have to use a workaround, but now you can. So that's basically what encryption is. You can create so encryption, you can, any image that you create from an encrypted volume, from any volume you create from an encrypted snapshot will by default be encrypted. If it's unencrypted, you will have the option to encrypt it, but you can't unencrypt it after. However, if you wanted to, you could copy the snapshot, and even when you're copying it, you're not able to unencrypt it. So that's just a quick look at encryption with EBS. Again, these services change quite frequently, and things that were not possible before are now possible. Things that were possible before sometimes aren't possible. So that's the importance of keeping up to date with the documentation. And if you're after the certifications, you have to really be on top of that anyway, because you'll have to renew the certifications every 2 or 3 years. Welcome to this quick bonus video on what is known as the Lifecycle Manager. This is actually not a very known feature, so I just want to give you guys a very quick introduction into how to use it, because as you've noticed, a lot of this work with creating snapshots and volumes and so on and so forth are a lot of manual work and a lot of repetitive work, right? So you can automate the snapshot creation using Lifecycle Manager. So you can use it to automate the creation, retention, and deletion of EBS snapshots, as well as EBS backed AMIs, but we're currently talking about snapshots. And when you automate snapshot and AMI management, it helps you to protect valuable data by enforcing a regular backup schedule, and it helps you create standardized AMIs that can be refreshed at regular intervals. It helps you retain backups as required by auditors or internal compliance. It helps you reduce storage costs by deleting outdated backups. It helps you create disaster recovery backup policies that back up data to isolated accounts, so on and so forth. So when combined with the monitoring features of services like Amazon CloudWatch events and Amazon CloudTrail, Lifecycle Manager provides a complete backup solution for Amazon EC2 instances and individual EBS volumes at no additional cost. So this is definitely a very useful little feature here. So we can go ahead and create a lifecycle policy, and within this policy we can determine what we're creating a policy for. So essentially for this one, we'll just create it for an Amazon EBS snapshot policy. So for snapshots, not for AMI, not from Amazon Machine Images. And then we can select a volume or the instance. And then, we can define tags, AMI roles. And then here, we can define a schedule. So like, for example, backup schedule or something, right? And then we can set the frequency, the hours, when it should start, the retention type, and how many snapshots to keep, like after how many numbers should it start deleting previous versions, and so on and so forth. So there's a lot of customizability that you can do here. You can add additional schedules and so on and so forth, and then you just create your policy, and that's it. And now you have a regular update happening, a regular backup taking place using snapshots, the snapshots that we're already familiar with, and it just happens automatically. So that's just a very cool little feature, very useful, but just hiding there in its own little place. So I just want to give you guys some exposure to it. So there is something called an Amazon EC2 instance store, and this basically provides temporary block level storage for your instance. The storage is located on disks that are physically attached to the host computer, and instance store is ideal for temporary storage of information that changes frequently, such as buffers, caches, scratch data, and other temporary content, or for data that is replicated across a fleet of instances, such as a load-balanced pool of web servers. An instance store consists of one or more instance store volumes exposed as block devices. The size of an instance store, as well as the number of devices available, varies by instance type. So not all instance types actually have the option for an instance store, and the virtual devices for instance store volumes are basically instance store volumes are ephemeral. So this is just temporary data, and you can only specify instance store volumes for an instance when you launch it. You can not detach an instance store volume from one instance and attach it to a different instance. So it's not like EBS at all in that regard. And data in an instance store persists only during the lifetime of its associated instance. If an instance reboots, whether that be intentionally or unintentionally, data in the instance store persists. However, data in the instance store is lost in cases such as underlying disk drive fails, instance stop, when the instance stops, when the instance hibernates, when the instance terminates. So in these cases, the data in the instance store is lost. Therefore, do not rely on instance store for valuable long-term data. Instead, use more durable data storage such as Amazon S3, Amazon EBS, which we just covered, or Amazon EFS, which we will cover in the next video. When you stop, hibernate, or terminate an instance, every block of storage in the instance store is reset. Therefore, your data cannot be accessed through the instance store of another instance. So essentially, there are certain instance types that will allow you to create an instance store with them. These, there's a long list of them. You can look it up. But essentially, the ones we were using, the T type instances that we were creating, do not support it. The C types support it. The D types, F, G, I, M, but not the T's. And so essentially, keep in mind that it is a physical disk that is attached to the computer, unlike EBS, where it's a network drive, it's a network disk. So there is no network in instance store. And that's why, the IOPS and the speed, etc., is incredibly fast. And so, in cases where you do need that, you can definitely consider it. So let's just jump straight into the AWS console and experiment a little bit with Amazon EC2 Instance Store. So here we are in the EC2 dashboard, and now we can go ahead and create or launch a new instance. And here under instance types, you can see that there's instance storage, EBS only. So the instance types that we've been using up until now, the T2 micros or the other T types, only allow for EBS storage. So we have to go quite a ways down until we see that we have instance store available. So let's go ahead and select this one, for example, and let's go into next, configure instance details, add storage. And here you can see that there is a default EBS volume or root volume attached. Okay, it's a GP2 EBS volume. The default that's attached to all the other instances that we've been dealing with. But on top of that, here you'll note that there's ephemeral 0. So the labeling of these instance store disks start from ephemeral 0, and they can go up to ephemeral 23. Okay, so these are the instance stores. You can see the size, and it's hardware encrypted. It's physically attached to the instance. So you can still add additional EBS volumes, but essentially now we have an ephemeral store. I'm not going to launch this because I don't want to pay for it, but that's essentially what an instance store is, and that's how you would create an instance with it. Again, not all instances support it, and again, do not use it for sensitive data, or for valuable long-term data. Hello and welcome back. In this video, we will be learning about a new service called Amazon EFS, which stands for Elastic File Storage. And this essentially, stands for Elastic File System. And at the time of recording this video, it is a relatively new service, and I'm sure a lot of things will be changed and updated. And it seems like Amazon is trying to, really put this into the center of a lot of its, trying to put a lot of focus on this service. So its importance will increase. And so you might need to spend a little bit more time going over this, depending on when you're watching this video, if it's been quite a while since I've recorded this video. But I'll give you all the basics of what EFS is. Now, EFS is a separate service. It's not going to be within EC2. It's going to be a separate service altogether. So essentially, it provides a simple, scalable, fully managed, elastic NFS or network file system, and it uses the NFS version 4.1 protocol, and it's for use with AWS Cloud services and on-premise resources. And it is built to scale on demand to petabytes without disrupting applications, growing and shrinking automatically as you add and remove files. And it eliminates the need to provision and manage capacity to accommodate growth. Okay, so it's a fully managed service, fully managed file system. And it is quite a bit expensive, especially when compared with EBS, but that's the price you're paying for having a fully managed service. So there are essentially two storage classes: the standard storage class and the infrequent access storage class. So you can put, files that you'll not be accessing for quite some time, or you'll be accessing infrequently, into the infrequent access storage class. And this will help you reduce costs because it's going to be much cheaper. I think it's like $0.025 at the time of recording this video for the EFS IA, whereas it's like $0.3 or something for the normal standard storage class. So essentially, EFS IA provides price/performance that's cost optimized for files not accessed every day. So by simply enabling EFS lifecycle management on your file system, files not accessed according to the lifecycle policy you choose will automatically and transparently move into EFS IA. So if you are successfully set up your lifecycle management, you won't even need to bother, finding files that are not frequently accessed and putting them into EFS IA. That can be done automatically for you. And I'll show you how to set that up. And that's very important, for saving costs. Because again, EFS IA storage, the EFS IA storage class costs only $0.025 per gigabyte per month. And so, while workload patterns vary, customers typically find that 80% of files are infrequently accessed, and thus they're suitable for EFS IA. And 20% are actively used, which means they're suitable for EFS standard. And this results in an effective storage cost as low as $0.08 per gigabyte per month. EFS transparently serves files from both storage classes in a common file system namespace. Now, EFS is designed to provide massively parallel shared access to thousands of Amazon EC2 instances, enabling your applications to achieve high levels of aggregate throughput and IOPS with consistent low latencies, okay? And it is well suited to support a broad spectrum of use cases, from just regular home directories to business critical applications. Other cases include big data analytics, web serving and content management, application development and testing, media and entertainment workflows, database backups, and container storage. Amazon EFS is a global service storing data within and across multiple availability zones for high availability and durability. And Amazon EC2 instances can access your file system across availability zones, regions, and VPCs, while on-premise servers can access using AWS Direct Connect or AWS VPN. So this is really a service that AWS is pushing into the spotlight. It's going to really increase importance in the future. And yeah, so I'll be comparing EFS to EBS in the next video. But for now, let's talk about some benefits of Amazon EFS. Scalable performance. So Amazon AFS is designed to provide the throughput, IOPS, and low latency needed for Linux workloads. Throughput and IOPS scale as a file system grows and can burst to higher throughput levels for short periods of time to support the unpredictable performance needs of file workloads. For the most demanding workloads, Amazon EFS can support performance over 10 gigabytes per second and more than 500,000 IOPS. Okay, so that's a benefit of Amazon EFS. Another benefit is that it's fully managed, and it provides shared file system storage for Linux workloads. It provides a simple interface allowing you to create and configure file systems quickly, and manages the file storage infrastructure for you, removing the complexity of deploying, patching, and maintaining the underpinnings of a file system. Also, it's cost effective. You pay only for what you use. There is no need to provision storage in advance like EBS, and there are no minimum commitments or upfront fees. And that's a huge advantage. When AFS Lifecycle Management, with AFS Lifecycle Management, you can automatically move files accessed less frequently to a cost-optimized storage class, reducing file storage costs by up to 92%. You can also use AWS budgets to monitor your file system costs. And when it comes to security and compliance, EFS allows you to securely access your files using your existing security infrastructure. You can control access to your Amazon EFS file system with POSIX permissions, Amazon VPC, and AWS IAM. Secure your data by encrypting your data at rest and in transit. Amazon EFS also meets many eligibility and compliance requirements to help you meet your regulatory needs. You can look up, a list of compliance programs in scope for Amazon EFS if you're interested. And then dynamic elasticity. Amazon EFS automatically and instantly scales your file system storage capacity up or down as you add or remove files without disrupting your applications, dynamically providing the storage capacity you need as you need it. You simply create your file system and start adding files with no need to provision storage in advance. And it's, POSIX compliant shared file storage, provides secure access for thousands of connections for Amazon EC2 instances and on-premise servers simultaneously using a traditional file permissions model, file locking capabilities, and hierarchical directory structure via the NFS version 4.1 protocol. Amazon EC2 instances can access your file systems across availability zones, regions, and VPCs, while on-premise servers can access using AWS Direct Connect or AWS VPN. So these are some of the benefits of Amazon EFS. As you can see, Amazon is putting in, a lot of effort to really push this service forward. We'll see where it goes, but right now let's do some hands-on. So here we are in the AWS Management Console. We've been using EC2 up until now, pretty much for everything. Even EBS was located within EC2. So was Instant Store. So was, AMI and all the other things we've been covering so far. But now we're going to go under storage and into EFS. It's a separate service marketed separately from EC2. And so let's go ahead and click it. And here we are in the Amazon Elastic File System, Scalable Elastic Cloud Native NFS file system. And you can see the pricing here. So yeah, like I said, we have the standard storage class, which is about 30 cents per gigabyte. And then we have the infrequent access storage, which is 0.025 or basically 2.5 cents per gigabyte. And then when you do have files stored within the infrequent access storage class, you will have to pay additional additional fee for requests. And that's because, that's the whole point of infrequent access. You're not supposed to be accessing it frequently. So, access will cost you. And then there is the provision throughput pricing. And you can use the Amazon pricing calculator to further calculate, if this is something that's going to be useful for you or not. Let's go ahead and create a file system. And we can give this a name. So let's call it EFS demo. And you will need to, so keep in mind, the EFS is meant to be accessible by, all types of, by, hundreds and thousands of EC2 instances and across multiple availability zones, and not just instances, even other services like, that Amazon provides can be integrated with or can access this file system. So you will have to specify a VPC. We have one VPC, so we can go ahead and select it and we create. And that's it. We have an EFS, an Elastic File System in place. It's being created. Now, if we click on it, we will see that currently we are only using 6 KIB or of storage within here. We have none in EFS IA, and throughput mode is bursting, performance mode is general purpose, and it's encrypted. Let's go into network, and in network we can see that since this is a region specific or a regional service, you have access to it from each availability zone. This is one of the distinguishing differences between EFS and EBS, is that EBS is locked to a specific availability zone, whereas EFS is available throughout the region in all the availability zones. And so there's a separate network interface ID for each, so you can use each of these to connect, or you can create security groups to attach to the EFS. So there are a lot of different ways you can do this. You can come into here and you can attach from here to an instance, or you can go into an instance, and so back and forth. So I'm just going to be going over one way to do it. So let's go into EC2. And in the dashboard, we have no running instances. Let's go ahead and launch some instances. Let's click this one, and let's go into configure instance. Let's launch 2 instances. Now, the whole point of what we're doing now is to show how EBS was focused more on having, individual volumes, individual storage for individual instances. And it wasn't really meant to be accessible from all your instances at once, even though there is multi-attach capabilities on some. But that's not really the intended purpose of it. But Amazon EFS is meant to be accessible by all your instances at once, like a central file system. So that's why we're creating 2 here, 2 instances, just so I can show how adding a file into one will actually create be able to be seen in the other one instantly. Whereas with EBS, we had to detach the volume and then attach it to the other instance. So in order to do that, we have to attach, or we have to add a file system. So we can, if we hadn't created one from Amazon EFS, we could have created a new one, but we do have one. So let's add the file system, and there we go, EFS demo. We only have one to pick from anyway, because we only have one. Now, again, Amazon EFS is accessed through a security group. So there is a security group layer on top of EFS, and other Amazon EC2 instances will need to have access to that security group. And and they have they themselves have security groups that can access that security group, because how when you're defining a security group, you can select not just an IP, but you can also select other security groups that can have access, or you can give access to. So instead of doing all of that, in the past, that would have had to been done manually. You would have to go into EFS, create a security group, and then go into your instance and then create another security group, and then give them each other access, and so on and so forth. But here now Amazon allows manages that for us, automatically create and attach the required security groups. It's that simple. You don't have to worry about it. So let's go ahead and review and launch. And let's acknowledge. And now we can view instances. Let's refresh. There we go. We have 2 instances now. Let's name these so they don't get we don't get confused between them. This is called first, and this one we'll call second. Now let's go ahead and connect to each. So let's connect to this one. Connect. Connect. And then let's connect to so now we have first and second, these 2 instances. Now, what we have to do now is, if you remember, even with EBS, we had to mount the devices onto our instances. So essentially, you have to also mount your Amazon EFS file system to your instances that, the instances you want to be able to access, to the instances that you want to have access to your EFS file system. And you can do that using the mount helper. So let's use mount, and this time the type of file system we're using is EFS, and we have to write in the EFS, our EFS file system ID. So this is the EFS file system ID. Let's copy that and let's paste it here, and we want to mount it to EFS. This is represents a root file, so the mount folder in the root folder, and then the EFS folder within that. So this is this is taken directly from the AWS documentation. So you can just take this. Again, this is the Amazon EFS file system ID, semicolon / space / MNT /EFS. Go ahead and click enter. Now we can see that if we go and check mount, we can see the file system has been mounted and it's EFS. Now when we go into the first EC2 instance, when we do ls mount, this is there is an EFS here, but it's not mounted. So if we were to, let's echo hello world into hello.text, or into mntefs / hello.text, let's go to the root user, and then let's go echo hello world mntefs hello.text. Now if we go into, we see that there's a file called hello.text, but if we do the same here, there's no file called text. So let's go ahead and mount this one as well. Sudo mount, type EFS, mount EFS. Now we see that there's hello.text, and we can actually cat, and we see that there's hello world. It's the same one that we put in here, because now these two have mounted onto their /mount/EFS folder the file system that has the file system ID as follows here, as shown here. So this is basically one way to mount your EFS file system to your instances. And as you can see, the advantage here, as opposed to EBS, is that, now, I can add potentially as many instances as I want, and they can all be attached to this very same file system. So they will have a shared file system, which is a huge, blessing, right? In many cases. And you can have multiple file systems as well. Now here, if you notice, it says reduce your storage price using lifecycle management. So that's definitely something you can set up. That's definitely something you can set up. If you're interested in using EFS, definitely take advantage of that. Just know that it exists, and essentially it'll it's a way of automating the management of your file system so that unused files will be automatically transferred into EFS IA, and therefore will save you or your institution or your company or whatever a lot of money. So that's it for EFS. Again, depending on when you're watching this video, maybe go over what the last exam focused on. Ask some people that took the exam and see if you see how much emphasis is being placed on Amazon EFS, and based on that you can know how much focus you should be putting on it when studying for the exam. But for practical purposes, you saw how to implement it, and then you can also set up the lifecycle management. We're just going to go over just very quickly the differences between EBS and EFS. I have been mentioning some of the key differences in the past videos, but here I just want to summarize everything just very concisely so that it's easy for you to decide which service would be best for you. So let's very quickly recap. EBS, stands for Elastic Block Storage. Every server needs a drive. EBS is essentially cloud-based storage for the drives on your virtual machines. So EBS is designed to store data in blocks attached to an Amazon EC2 instance, similar to a local disk drive on your physical machine. And you need to mount EBS onto an Amazon EC2 instance, right? Whereas EFS is Elastic File System, on the other hand, is automatically scalable. This means that you need not to be worried about running applications, as there won't be any problems even if the workload suddenly becomes higher. The storage will automatically scale itself to compensate for that. And now if the workload decreases, the storage will itself scale down as well, so you don't pay anything for the part of the storage that you don't use, as opposed to EBS. And Amazon EFS is especially helpful for running servers, shared volumes, big data analysis, any scalable workload you can think of. Now let's jump into this table very quickly. So I tried to summarize some of the key differences between the two services. When it comes to storage type, right, EBS is block storage, EFS is object storage. That's pretty straightforward. When it comes to performance, EBS is not really scalable. How would you scale it? You can manually scale the size of the volumes without stopping the instance. The baseline performance comes with 3 IOPS per gigabyte for general purpose volume, and if you do want to increase the performance, you would need to use provisioned IOPS. So there's some scalability, but not really. Whereas in EFS, this is a highly scalable managed service, and it supports up to 7,000 file system operations per second. So that's quite a big difference. When it comes to data stored, EBS stores data in the same availability zone, and replicas are made within the availability zone for higher durability. EFS stores data in the same region. Replicas are made within the region. So, and then when it comes to data access, EBS can only be accessed by a single EC2 instance. So that's one of the key defining differences between the two services, because EFS can be accessed by 1 to thousands of EC2 instances from multiple availability zones concurrently. So that's quite a advantage there. And when it comes to file systems, EBS supports various file systems, like X3 and X4, whereas EFS is a file storage service for use with AWS EC2. So, but it can also be used as a network file system for on-premise services using AWS Direct Connect. And they both use the same encryption, AWS KMS Managed Customer Master Key, or CMK, and AES 256-bit encryption standards. That's pretty standard. Availability, they're both very highly available. Durability, so when it comes to durability, EBS, is 20 times more reliable than normal hard disk, but EFS is highly durable. Like, it doesn't compete with EFS in that regard. Storage, but when, for availability zone failure, EBS cannot withstand availability zone failure without point-in-time EBS snapshots. EFS, on the other hand, every file system object is redundantly stored across multiple availability zones, so it can survive one availability zone failure. Storage size, EBS actually does have a maximum limit, on its volume size, and that's set at 16 terabytes, whereas EFS has no limitation on the size of the file system whatsoever. You can potentially scale up to like petabytes of data, petabytes of files. And interestingly enough, EBS has no limitation on file size, whereas EFS does. So EFS actually has a maximum size, file size of 47.9 terabytes, which is pretty interesting. And finally, data throughput and input output, EBS, if you recall, has the SSD and the HDD backed storage devices. Use of SSD backed and provisioned IOPS is recommended for dedicated input output operations as needed, whereas EFS has a default throughput of 3 gigabytes per second for all connected clients. So yeah, these are just some quick comparisons. Again, EFS is quite new in terms of as far as AWS services are concerned, so it might still take some time for its place to really settle down and for it to really become clear what it should be used for and when it should be preferred over other storage systems. But right now it's already very clear that the fact that you can have it accessed by potentially thousands of EC2 instances is a huge advantage. Its elasticity, its scalability, and so on and so forth. So that's it for this section. We finished EC2 storage. We're going to be moving on to S3 in the next section, so I will see you there. Thanks. So in this section, we're going to be learning about Amazon S3, also called Amazon Simple Storage Service. And this is quite an important topic. A lot of people don't really realize how useful S3 is. When people think of data storage, they generally think of databases and that kind of stuff. S3 is so easy to use and so practical that it's used in a lot of applications, a lot of websites. You can actually create websites using Amazon S3, as we're going to see later on in this section. So don't let the simplicity fool you. It is called a simple storage service, but it is actually pretty simple, but that doesn't take from its importance. So what is Amazon S3? Amazon S3 is a simple web services interface you can use to store and retrieve any amount of data at any time from anywhere on the web. And that's basically where, its simplicity comes from, right? You don't need to, log in or have database credentials or have to query or have to use some kind of client-side program for reaching the data or anything like that. It's just very simple, any amount of data, no limits, at any time, right? Anywhere on the web. That's what makes it really simple. And it is, one of the building blocks of AWS, one of the fundamental services, one of the core services, along with EC2. So it's very important, and it offers industry-leading scalability, data availability, security, performance, what have you. And some of the use cases are websites, mobile applications, backup and restoration, archiving, enterprise applications, Internet of Things devices, big data analytics, so on and so forth. So it has a lot of use cases. Amazon S3 is intentionally built with a minimal feature set that focuses on simplicity and robustness. So I'm going to list for you some of the advantages of using Amazon S3. Creating buckets. You can create and name a bucket that stores data. Okay. It's literally just a bucket, okay, that stores data. And buckets are essentially like the fundamental containers in Amazon S3 for data storage. Now you can store an infinite amount of data in a bucket. You can upload as many objects as you like into an Amazon S3 bucket. Each object can contain up to 5 terabytes of data. And each object is stored and retrieved using a unique developer assigned key. Okay. Now you can download your data and enable others to do so. Download your data anytime you like, or allow others to do the same. So you can set permissions, you can block people from accessing your data, you can do all of that. But essentially, once you allow it, it's very easy for people to just use the link and just access your data. Okay. You can grant or deny access to others who want to upload data into your Amazon S3 bucket. You can grant upload and download permissions to 3 types of users. Authentication mechanisms can also help keep data secure from unauthorized access. Okay. And S3 buckets use standards-based REST and SOAP interfaces designed to work with any internet development toolkit. Now, SOAP supported over HTTP is depreciated, but it is still available over HTTPS. New Amazon S3 features will not be supported for SOAP. So, we recommend that you use either the REST API or the AWS SDKs. Now, let's go over some Amazon S3 concepts that we should become familiar with before we dive in. So, the number one concept, the most important thing to know about Amazon S3 are the buckets. A bucket is essentially a container for objects stored in S3. Every object is contained in a bucket. For example, if you have an object named photos/puppy.jpg, and this would be an image, right? A JPEG image. And it's stored in a bucket called AWS example bucket 1 in region US West Oregon, let's say, then it would be addressable using this URL here. Okay. So that would be the bucket name, and then the the region, and then the name of the object itself. Now, buckets serve several purposes. They organize Amazon S3 namespace at the highest level. They identify the account responsible for storage and data transfer charges. They play a role in access control, and they serve as the unit of aggregation for usage reporting. You can configure buckets so they're created in a specific AWS region. And you can also configure a bucket so that every time an object is added to it, Amazon S3 generates a unique version ID and assigns it to the object. Now, S3 buckets must have a globally unique name. So this name here must be globally unique. S3 bucket naming convention includes no uppercase, no underscores, and it cannot be an IP. It must start with a lowercase letter or a number, and it must be between 3 and 63 characters long. Okay, that's how you would name a bucket. Okay. So even though the names are globally unique, S3 is a region-specific service. Now, another concept we should be familiar with when talking about Amazon S3 is objects. Objects are the fundamental entities stored in Amazon S3, and they can consist of, or they do consist of, object data and metadata. And the data portion is opaque to Amazon S3. The metadata is a set of name-value pairs that describe the object. These include some default metadata, such as the date last modified, the standard HTTP metadata, such as content type, etc. You can also specify custom metadata at the time the object is stored. An object is uniquely identified within a bucket by a key name and a version ID. Now, objects stored in S3 can be up to 5 terabytes in size, like we said. And the name, and like if you do have, but the thing is you can only upload up to 5 gigabytes at a time. So if you do have an object that's larger than 5 gigabytes, you will need to do a multi-part upload. Now there are some other, little key terms when it comes to objects, that we'll be going over later on. The key name is the name you assign to an object. The version ID is a string that Amazon S3 generates when you add an object to a bucket and is uniquely identifies an object. Value is the content you're storing. Metadata is a list of text key and value pairs which you can store information with regarding the object. There are sub-resources which Amazon S3 uses to store object-specific additional information. And then we have access control information. You can control access to the object you store in S3. But all of these, we'll cover in later slides. Now, another important concept is what's known as keys. So a key is a unique identifier for an object within a bucket. Each object in a bucket has exactly one key, okay? And the combination of bucket, key, and version ID uniquely identify each object. So you can think of Amazon S3 as a basic data map between bucket, key, version, and the object itself, okay? Every object in Amazon S3 can be uniquely addressed through the combination of the web service endpoint, bucket name, key, and optionally a version. And I'll show you how to do versioning with S3 as well. So, for example, in this URL, doc is the name of the bucket, and 2006-03-01/Amazon S3.wsdl is the key. Okay, and don't let this slash fool you. This slash is actually part of the key. There aren't really such things as directories in S3, but using the slash can help you mimic a directory structure. Regions. So you can choose a geographical AWS region where AWS will store the buckets that you create. You might choose a region to optimize latency or minimize costs or address regulatory requirements. These might be, some of the factors behind your decision for which region to use. Objects stored in a region never leave the region unless you explicitly transfer them to another region. For example, objects stored in the Europe or Ireland region never leave it. You can only access Amazon S3 and its features in AWS regions that are enabled for your account. Okay, so this was meant as just an introduction to S3. So let's just jump right in and start playing around with S3 and look at how we can create buckets and objects, so on and so forth. Really the best way to learn. So I'll see you in the AWS console. So here we are in the AWS Management Console, and we want to start working with our S3 service. So we are going to go into go under storage into S3. Okay, so we're now moving away from EC2. We did explore EFS, right? But EFS was a file storage system. S3 is an object storage system, just unstructured, raw data. It's just much simpler. No need to integrate anything or, do any of the things we had to do for EFS. So let's just go into S3. Now, every object in Amazon S3 is stored in a bucket. Before you can store data in Amazon S3, you must create a bucket. So conveniently, we land in the buckets page, okay? And you can see, there are a number of ways to access creating a bucket. We can create a bucket from here. We can create a bucket by clicking this. Since we have 0 buckets right now, you're not charged for creating a bucket, okay? You are charged for storing objects in the bucket and for transferring objects in and out of buckets, right? And the charges that you incur won't be that much. If you're following along with me, it should be free if you're using the free tier. And even if you're not, it should be less than like $1. So no worries there. So let's create a bucket. Let's click the orange create bucket button. And the first thing we have to do is we have to specify a bucket name. Okay. And it has to be DNS compliant, right? Remember, we said that it has to be unique across all of Amazon S3. So not just on your account, it has to be unique across all the accounts on Amazon S3. It should be between 3 and 63 characters long. It shouldn't contain any uppercase letters. It should start with either a lowercase letter or a number, okay? And after you create the bucket, you can't change its name. So let's call this, number 1 AWS course. And let's hope that that's not taken. Okay, we'll see when we're trying to create the bucket if that's taken or not. Now, avoid including sensitive information in your bucket names, such as account numbers and that kind of stuff, because the bucket name will be visible in the URL or the URLs that point to the objects in the bucket. Okay, so keep that in mind. Now we have to choose an AWS region where you want your bucket to reside. I'm just going to keep it with the default region that I'm in, US East 2. Now you should choose a region that is close to you geographically to minimize latency and costs and to address regulatory requirements. Objects stored in a region never leave that region unless you explicitly transfer them to another region. Okay. Now, as we scroll down, we see this section, bucket settings for block public access. We're just going to keep these at the default. By default, we will block all access. It's recommended that you keep this enabled for security purposes, and only when you want to expose an object or a bucket would you then go in and update that setting. Now, we're going to talk about bucket versioning in another video. You can add tags, and encryption will also be another video. So let's go ahead and create our bucket. Now, as you can see, we've successfully created bucket number 1 AWS course. To upload files and folders or to configure additional bucket settings, choose view details. So we don't really care about these notifications at the moment. Here we have our bucket in this particular region. Now, again, keep in mind that Amazon S3 is a global service. S3 as a service is global. However, buckets are region specific, okay? And we can conveniently see that, the access. So we know that this is not public. And now it's time to add an object to our bucket. So after creating a bucket in Amazon S3, we're ready to upload an object to the bucket. An object can be any kind of file. a text file, a photo, a video, etc. And how we're going to do that is we're going to click on our bucket. Now we're in the bucket in Amazon S3. We are in the bucket called number 1 AWS course. Okay. And here we have, two different ways of uploading objects to this bucket. Now we can also create a folder. Now keep in mind that there are no such things as folders in S3. So basically the slashes that you include in your bucket names or the keys will be used by Amazon to kind of give the impression that you're using folders. But there is no file system or file structure in S3, so keep that in mind. Okay, so let's click on upload, and here we can either add files or we can add a folder. Again, adding a folder is just going to prefix the name of that, those files with the name of the folder. So it's just going to be a longer name with a slash in the middle somewhere. So let us add files. We have burger. Let's add puppy as well. There we go. Files and folders, 2 total, etc. We're not worried about versioning. Let's upload. Now it's uploading, and there we go. We now have these 2 objects within our bucket, and we can go to our bucket, and here we go, right? We can see them. Now if you click on one, you can view the details for that bucket. So in our case, we already know that it's an image, JPEG, its size, etc. But what's interesting for us here is the object URL, and this is just like how we saw in the slides. We have the name of the bucket, so number 1 AWS course, and then we have the region US-East-2, and then we have the name of the object. Okay, so this is the object URL. This is how you would expose your bucket or your object to the world, or how you would share any objects you have in S3. Now, if we click on this, you'll see that it's access denied. And the reason for that is because, if you recall, we had blocked all access to this object. If we go into permissions, we can see that we, as the owner of the account, we have read and write access, but everyone else, has no access. Okay, so this is blocked off to the public by default, and we're using the public object URL here. So it's quite naturally not going to work, because that's how anybody else would access the object. Now you might ask, in that case, how do we view our own objects, right? We just uploaded something and we can't view it because it's blocked off to the public. Do we have to unblock it and have everybody be able to see it for us to see it ourselves? No. If we go to object actions, we can click on open here, and this will use another URL, and this URL will have like an encrypted set of credentials and like your account. There'll be some sort of signature notifying AWS that it is you from your account that is viewing this image. So you're basically viewing it from within your account, and so now you can see the object, right? But this will be temporary. You can't really share this or use this with other people. It's just for you to see your object, whereas this is the official link or the official address to the object if you do want to share it with people after you have allowed access or allowed permissions for it to be viewed. So we can go back into number 1 AWS course, and we can do the same thing with puppy, object actions, open, and there we go, we see the puppy. And we can also click on the object directly, and from actions open like so. Now if you want to, you could download your object as well. So if you click download here, it's going to download as burger.jpg. We can download it as something else as well, and so on and so forth. Now we can go back in here and we can create a folder. Okay, this is how you create a folder. You can write in like favorite images, and we create the folder. Now S3 will make it seem like you have a folder here, right? There's a folder icon, and there's no extension. It ends in a slash. You click it and you enter into a quasi folder in which you can upload more images. But keep in mind, again, there are no folders. It's just Amazon is making it easy for you to manage your object names. When it sees a slash, it's interpreting that as a quasi folder, but it's not really a folder. Okay, so we can copy objects that we already have in our S3 bucket into a quote-unquote folder. Okay, so let's copy the burger. So let's click it, and then we copy, and we can select a button. We can select a bucket to copy this object into. But if we don't have to memorize the names of our buckets every time, so we can just click browse S3, and we click on this here, create destination, and as you can see, the destination is essentially the bucket name followed by a slash, followed by the name of the folder, followed by a slash. Okay, that is the destination of where we're trying to copy this image to. And then when we click copy, we can go back into buckets, number one Amazon, number one AWS course, and then go into favorite images, and there we go. We have our copied object here. Now, like I said, you're not charged for creating buckets, but you are charged for the storage of the objects within the buckets. So before we end here, let's go ahead and see how we can delete objects and buckets. So if you just click on an object and you click delete, you have to type in permanently delete, and you delete your object. We go back into number one AWS course. Let's just select all of them, delete, permanently delete, and there we go. We've deleted all our objects and all our we've deleted all our objects. Now we can delete our bucket. So just click on it, and now we have to type in the name of the bucket, just so we can confirm to Amazon we intend to do this. We could have deleted it without deleting the objects as well, but it's generally good practice to delete your objects first, so you can see what you're deleting and not make any mistakes. So that's it. That's just some hands-on with some S3 buckets and objects, how to create them. It's very easy to play around with them, download them, copy them. You can move them. You can create more buckets in other regions, so on and so forth. So in the next videos, we're going to be covering versioning and encryption, and security and that kind of stuff. But basically, in terms of practical use, this is all you need to know for Amazon S3. Hello and welcome back. Let's talk about AWS S3 versioning. So versioning in Amazon S3 is a means of keeping multiple variants of an object in the same bucket. Okay. Now, once versioning is enabled for a bucket, Amazon S3 automatically generates a unique version ID for the object being stored. And you can use the S3 versioning feature to preserve, retrieve, and restore every version of every object stored in your buckets. It enables you to easily recover from both unintended user actions and application failures. And after versioning is enabled for a bucket, right, if Amazon S3 receives multiple write requests for the same object simultaneously, it stores all of those objects. which might be very useful in certain applications. Version enable buckets enable you to recover objects from accidental deletion or overwrite. Buckets can be in one of three states. They can either be unversioned, they can be versioning enabled, or versioning suspended buckets. The versioning state applies to all of the objects in that bucket. Objects that are stored in your bucket before you set the versioning state has a version ID of null. Something important to remember is that after you version enable a bucket, it can never return to an unversioned state. But you can suspend versioning on that bucket, and that's why we have the three states. Now with versioning, if you delete an object, Amazon S3 inserts a delete marker instead of removing the object permanently. And the delete marker becomes the current object version. If you overwrite an object, it results in a new object version in the bucket. So you can always restore the previous version of an object. Now by default, as you saw, S3 versioning is disabled on buckets. So we must explicitly enable it, as we're going to be doing in this video. So let's jump right into the AWS console and start playing around with versioning. So here we are on the console, AWS console. Let's go ahead and create a bucket, and let's call it what we just called it in the last video, number 1 AWS course, and we're blocking all public access, and we go ahead and create the bucket. And then let's upload our files. Upload. And if we go into our bucket and we go into properties, we can see that versioning is disabled. Bucket versioning has been disabled. In fact, it's disabled by default. Okay. So we can go ahead and edit this. And you know, how do we get into there? We went into our buckets. We clicked on our bucket name, the bucket that we want to, change the versioning status of. And then we went into properties here. So there are a lot of different tabs here. We're going to be covering them. But we go into properties, and under properties, we have bucket versioning disabled. So let's go ahead and edit this. And we can enable bucket versioning. And now we can go ahead and save the changes. And what happens now is if we go into our objects and refresh, here we can see that there is now a switch for listing versions of objects. And when we turn it on, we now have a version ID showing, right? Before we didn't have a version ID. Now when we list version, we can see that the version ID for these two are null. And that's because we have enabled versioning after these objects have been uploaded. So the version ID will be null. Now, if we were to upload the same file, let's upload burger, for example. Okay. It has the same object name, the same destination. Everything is the same, right? It's the exact same object. But since we have versioning enabled, if we go back into the bucket, okay, we see that, the timestamp has been updated. Okay. It is it is a newer object, but it has not been overwritten. And how do we know? We can list versions, and we can see the original object here with a version ID of null. And now we have the new version, which has this version ID here. They're the same object to us, but to S3, they're two different versions. And so we can do that again, right? Upload, add files. And again, list versions, and there we go. So that's how you continually, like from now on, all these objects will have versions assigned to them. And in fact, what we can do is let's delete this puppy. We want to permanently delete. Now we have no puppy image. Let's upload it for the first time. See, it comes with a version ID. Now that version has been enabled, unlike Burger, which was uploaded before versioning had been enabled. Now, what if we wanted to delete burger.jpg? Let's click delete. And here we say deleting the specified objects adds delete markers to them. If you need to undo the delete action, you can delete the delete markers. Okay. So we can go ahead and write delete and see what they mean by that message. Here, right, when list versions has been disabled, versioning is still enabled, but we're turning off the option to see the different versions currently in this panel here, and we don't see a burger.jpg. We only see a puppy.jpg. But if we turn on list versions, we can see that burger still exists, okay? But what S3 has done is add a delete marker, okay? So that basically makes it seem to the, anybody who's accessing the S3 bucket that that object has been deleted, but we have the option of rolling that back. So if we delete this, we're back where we were, okay? So how would you delete the whole object? You would have to delete all the versions. And now we no longer have burger.jpg there. So versioning is very useful. And, when you're creating a new bucket, you can enable it by default. So you can enable it here, and then you can create your bucket, and then that will be enabled, automatically from the beginning. Now, one last thing we can look at is if we go into properties, we can see that bucket versioning has been enabled. Now, if we want to disable it, we can't. We can't disable it after it's been enabled. We can only suspend it. And that means this suspends the creation of object versions for all operations, but preserves any existing object versions. Okay. So if we were to upload another version of the puppy file, we'd see that we have two versions of this puppy file. And now if we were to go into properties, edit, suspend, from now on, there's no any further objects added to this bucket will no longer have a versioning enabled, but we will still have the two versions of puppy. Okay. Now, don't hesitate to go yourself and to experiment. And if you have any questions of how things work and that kind of stuff, try it out yourself. Like I said, you're only paying for the storage, and since they're small files, it's not going to be that much. And in any case, you can delete buckets after you've used them to experiment. So that's it for versioning. In this video, we're going to be covering S3 encryption. Now, encryption is a very important feature of S3, especially when you're working with clients or at a company where security is very important. One of the biggest factors that held companies back, when it came to migrating to the cloud, was the fear of, data security. And S3 does its best to mitigate this issue. It offers you quite a few options for encrypting your data on a very, on a nice spectrum of, how much control do you want over the encryption. You can let AWS manage the encryption, but if you don't, trust AWS for some reason, you can do it on your end. So there's a whole spectrum of options and possibilities for you when it comes to encrypting your data when working with S3. We're going to go over those together in this video. So now the different ways of S3 encryption are broken down into essentially server-side and client-side encryption. So server-side encryption is where you can request Amazon S3 to encrypt your object before saving it on disks in its data centers, and then decrypt it when you download the object. So essentially you're letting you're outsourcing the management of your encryption to Amazon. And within this option, there are still 3 different ways you can do it. And again, each of them is, different in the trade-off between handing off security to AWS or taking it into your own hands. So you have the option of using customer managed keys, and these are stored in AWS KMS, which we haven't covered yet, but this adds a little bit more in terms of security. You're able to manage it a little bit more, even though the keys are stored on an AWS service. They're external to S3, and you're just utilizing them within S3, so you have a little bit more control. You could also just go the Amazon S3 managed route, where Amazon S3 will essentially encrypt your files for you and create the keys for you and manage the keys and everything. So you're not really dealing with the keys, but AWS is doing it for you. And then you have the customer provided encryption keys. And this one, we're not going to really be going over because this requires the CLI to do, but that's also an option that's there. And these are the abbreviations, just in case, they do come up on the exam. So SSE KMS, SSE S3, and SSE C. And then, obviously you can do client-side encryption as well. So you can encrypt data client-side and upload the encrypted data to Amazon S3. In this case, obviously you're going to be managing the encryption process, the encryption keys, and the related tools. Because essentially, Amazon doesn't have to know that it's encrypted, right? You're just uploading a file. It just happens to be encrypted before you uploaded it, right? So it's just going to manage it as it manages any other files, but you're going to be, you're going to have encrypted it beforehand, and when you download it, you're going to need to decrypt it and so on and so forth. So this would be the most secure option. If you are working for a client or at a company that is really concerned with their S3 data, and for some reason they still don't trust the cloud, or they don't trust AWS despite all their, regulations and all of that, you could definitely do the client-side encryption method and just set up a system on site where all files traveling in and out of your network are encrypted and decrypted before they're sent to S3. So now let's dive into a little bit more detail on each of these. So when it comes to server-side encryption, okay, Amazon S3 server-side encryption, SSE, is the simplest data encryption option available, okay? And these can be broken down into SSE S3 and SSE C. So SSE encryption manages the heavy lifting of encryption on the AWS side and falls into 2 types, SSE S3 and SSE C. The SSE S3 option lets AWS manage the key for you, which requires you to trust them with that information, obviously, right? You have to trust that AWS is actually, using keys and actually encrypting and decrypting. And so again, that's, a trust issue there. Like if you actually do trust AWS, this is not going to be a problem for you. If you don't, and it just might be that, the security protocols of your company or whatever by default don't trust third-party services or third-party companies in managing their data, which is completely understandable. In that case, SSE S3 obviously will not, it'll essentially be the same as just using using S3 without encryption, right? From in that mindset. So the SSE C option similarly manages encryption and decryption of your data for you, but uses a key provided by the customer. And again, this requires a CLI. So we're not going to be going over how to do this, but know that this does exist as an option. Now, when it comes to client-side S3 encryption, S3 client-side data encryption puts all the responsibility for the encryption heavy lifting onto the user. And obviously this comes with added security. So there's always that trade-off, right? You know, it's going to require more work and more management on your side, and sometimes more risk in terms of like being able to properly manage all of that. And the trade-off is, you know, it's increased security, it's more private security, you know, it's security you're in control of. Whereas, you know, you might not want to bother dealing with the keys and encrypting and decrypting on your own every time. So you kind of outsource that responsibility to AWS, but then the trade-off is, you know, you got to trust them. You're kind of in their hands when it comes to security. So S3 client-side data encryption falls into two types: server-side master key storage, also abbreviated as SSE KMS, because it's using the KMS AWS service, which we'll cover later, and client-side master key storage. So in server-side master key storage, you can store your master key server-side in the AWS KMS, and you know, it'll use an API or whatever to like communicate with KMS and manage that encryption and the keys and that kind of stuff. And then in client-side master key storage, your master keys aren't stored on AWS servers, and you take full responsibility for the encryption. And again, this one we won't be covering on our own because it's going to be up to you what method you use or what tools you use for encrypting your data before you upload it onto S3. So that's essentially, you know, up to you. It's in your control. So with that, let's go into S3 and let's see how we can start encrypting our files, or objects as they're referred to in S3, and our buckets. So here we are in the console again. Let's jump into S3, and we have our bucket we made previously called #1 AWS course, and we've set up versioning on this. So we have two different versions of Puppy, and the latest one, you know, was uploaded obviously 3 minutes, and you know, 3.5 minutes later than the first one. Now let's go ahead and upload a new file. Okay, or before we do that, let's actually go into the uploaded version and let's see what kind of encryption this has. So server-side encryption settings, default encryption disabled. Remember, when we were uploading by default, this is disabled. So neither this version nor the one before it has any sort of encryption on the file. Encryption disabled. Okay, now let's upload a new version of this file. Add files, and let's go ahead and select Puppy. Now before we upload, let's open up additional upload options. Let's go all the way down. Oh, and there we go. Server-side encryption settings. So this is where it's disabled. So if we had just continued uploading this file as we've done the other ones, it would have had no encryption on it. But for this case, let's go ahead and enable encryption. And we're presented with two options. We have the SSE S3 version, and this is the one where Amazon S3 creates, manages, and uses the keys for you, for the encryption key. Or you can use the SSE KMS. For now, let's just go with SSE S3, and let's upload this image. Now we've uploaded this image. Let's exit. Let's list versions. And now we have a new version of this image. Okay. Let's click on this image. And now under encryption settings, we can see that default encryption has been enabled, and we're using the SSE S3 server-side encryption method. So this image is encrypted by Amazon S3, and Amazon S3 is managing the master key and the encryption key and all of that for us. So we don't have to concern ourselves with having to encrypt or decrypt or manage keys and that kind of stuff. So does this mean that the previous version of this image also are encrypted now? Let's go ahead and check. So let's open up the previous two versions. And when we go down, we see that default encryption is disabled for this, and it's also disabled for this one as well. So this means that encryption on S3 is based on image and version. So it's not based on the file itself. It's based on object and version. I'm sorry, not image, because your files don't have to be, your objects don't have to be images. They can be anything. They're just images in our case, right? But it's based on object version. So, you know, if you start encrypting after a certain point, you know, the same objects, previous versions will not all of a sudden become encrypted as well. So that's something you should be careful of. If you do decide to switch over to encrypting, make sure that, you know, your previous files are also encrypted, so on and so forth. Now, so we've done SSE S3, server-side encryption. Now let's try the KMS managed encryption. So let's upload another version. Go down to additional settings. We'll enable encryption. Now let's do the SSE KMS. So SSE KMS, there are a couple of ways you can do this, right? You can, again, outsource the management of the keys to AWS, but this time AWS will use, you know, KMS. We'll use a KMS service. It'll take care of managing the keys, but it'll now be, you know, on a KMS service, and then you'll be able to, you know, go into KMS and see what's happening if you wanted to. Or you could choose from your KMS master keys, right? And we're not going to do that in this video because that's going to require some knowledge on KMS, which we'll cover later. But you know, if you have keys on KMS already, you can go ahead and use those. Or if you have a KMS key on another account, or, you know, that belongs to somebody else or something like that, you can use a, you know, an ARN to reference that key and use that here as well. But for now, we're going to let AWS manage it for us, but we're going to let them manage it using KMS. Now, obviously, there's also the SSE C option that I mentioned in the slides, but again, that requires a CLI, and that option is not available through the console, you know, the web console for AWS. So we're not going to go into that. So let's create an AWS KMS managed encryption, and it's uploading now. Exit list versions. Now when we go into the latest version and we go down into encryption, we can see that's enabled, and it's AWS KMS or SSE KMS, and this is the reference to the master key. And, you know, if you wanted to, you can go into KMS and you can manage, you know, you could see what KMS is managing or what AWS is managing, but essentially it is now not encrypted or decrypted within S3, but it's done within KMS, which is, you know, another service. And so it does add an extra layer of security and transparency to the whole process. But again, if you were to go back and go to the one previous version of the same file or the same object, you would see that it's encrypted using SSE S3. So again, you know, just because you change the way an object is encrypted for a version doesn't change the way it's encrypted for any previous or future versions for that matter. So if you did want to just make sure that all your files are encrypted by default, we can actually change the encryption settings of the bucket itself. So here we've been just working with objects, right? Whenever we upload an object, we decide on how it should be encrypted. But if we go into properties, just like how we turned on bucket versioning, we can set default encryption as well. So if you edit this, you can enable it, and the same settings are presented before you, you know, just like how we picked SSE S3 for uploaded objects, or we selected you know, SSE KMS. We can do the same thing, but for the bucket. So let's, you know, just to keep things simple, Let's select SSE S3, save changes. Okay. Now, when we go into our objects, let's refresh just so the layout fixes itself. There we go. And we list versions. We go to the first image or the first version. It's still not encrypted by default. Okay. And we go into the last version, and it's, remember the bucket version, the bucket encryption method now is SSE S3, but this one is SSE KMS. Why? Because that's how we uploaded that object, right? Now, though, if we upload a new object or a new version of an existing object, so let's go ahead and upload, let's say, puppy. When we go into additional upload options, we can see that server-side encryption settings are enabled by default, and the type of encryption that's going to be used by default is the one that's enabled by default by the bucket. So you can override the default encryption bucket settings, and you can choose to go, like, let's say SSE KMS. But by default, if you don't do anything, even if you don't you don't even have to open up this menu anymore, these options anymore. If you just upload, what's going to happen is that this object is now going to be encrypted by default using the the buckets encryption settings. So we can go down into here, and there we go. It's enabled SSE S3. Okay, so that's pretty much it for encryption. There's SSE C that we didn't cover, and obviously client-side encryption will be up to you. You're just going to encrypt it on your end and just upload files as you would normally to S3, and S3 doesn't have to know that it's encrypted, and they don't care. They're just going to manage the file as if it's a normal file. So that's it for this video. Hello and welcome back. And in this video, we're going to be discussing S3 security. So this is also a very important topic, right, for S3, because whereas with encryption, we defined data security in terms of who is actually able to read the data once they've been able to acquire it. But with security, we're limiting who can actually access it in the first place. So they both play a very crucial role in securing your S3 data and your S3 services. So a very common way of securing S3 objects is through policies. And policies are defined as JSON objects, just like with any other service on AWS. And I'm going to be showing you how we can create S3 policies without really knowing how to structure JSON objects in the hands-on section of this video. And these policies can be set at two different levels. They can be set at the resource level. So, you can have an S3 bucket policy or a KMS key policy, or they can be set at the identity level. So you can have an IAM policy and determine how, different identities are able to access your S3 buckets and objects. A resource-based policy is defined per S3 bucket, namely, bucket policy or KMS key, key policy. Whereas an identity-based policy is defined per IAM user or role. I'm not going to be going into defining identity-based policies for S3 buckets in this video because that's, more of an IAM or more of a general policy topic. And here we're just talking about S3 security. So know that just like, we could create policies for any other service on AWS for an AIM user or role, you can also do that for S3 as well. So in this video, we're just going to be mainly focusing on the resource level policies, or more specifically, the bucket policies. And you can remove public access from all your S3 buckets unless it's necessary. An exception would be that the buckets contain public data, maybe it's a website or something like that. And this is, best practice. There have been issues in the past where leaks have occurred due to buckets being public by default, but AWS has changed that. So, just make sure that unless the use of your S3 bucket is specifically for public access, just make sure that you do remove all public access from your S3 buckets. and definitely follow the principle of least privilege when configuring access to S3 buckets. That's a very standard best practice for security of all types of systems. But the same applies for S3 as well. And always use encryption to encrypt S3 files and the S3 bucket itself. So we learned in the last video how to encrypt both S3 files as well as buckets. So just do that by default. It doesn't hurt you. It doesn't really affect anything. It doesn't, the cost doesn't change. The speed doesn't change. Nothing really changes. So it's, there's really no reason to do it. In the worst case, just pick the default SSE, S3, the default option. So you don't even have to deal with keys and that kind of stuff, but always encrypt your files. That's generally accepted best practice. And it's recommended to enable S3 bucket logging in all S3 buckets. So, if a breach does happen or some sort of, issue arises with encryption or security or data access or data leaks or something like that, you have, kind of a trail that leads you to where, the problem arose from, like what the issue was that caused the breach, so on and so forth. But again, we're not going to be covering anything except S3 security, bucket policies in this video. So, but that, it's worth mentioning. Now, when it comes to S3 bucket policies, they are basically a resource-based AWS identity and access management policy. So they are, JSON objects, and you have complete control over basically everything. So whatever, that's the reason they're JSON objects, because there's so many different possibilities, so many different combinations and options that you can basically implement when it comes to security policies. So by default, all Amazon S3 buckets and objects are private. So again, before that wasn't really the case, and breaches happened and leaks happened, so on and so forth. So now by default, they're all private. Only the resource owner and the AWS account that created the bucket can access that bucket and any object it contains by default, right? So if you want it to be different, right, if you want it to be viewable by somebody else or something like that, you're going to have to change the policy or change the settings. And like I mentioned, they are JSON-based policies consisting of resources, so buckets and objects, actions, a set of API to allow or deny something. So when you're setting the policy, you can allow for something or deny for something. I'm going to show you an example in the next video. It's going to make more sense. And then the effect, again, allow or deny. And then the principal, the account or user to which the policy is applied. So you can set certain policies depending on the account or the user. And policies are a very deep topic. It's not something we can just cover in one video, but I'm going to be showing you how to create, just a very simple policy for S3 security. But, everybody is going to have different needs when it comes to security policies. So generally, you can just search on Google, like for your particular need, and then like how to create the policy for S3. And then you most likely find some AWS doc that explains to you exactly like the different headers and different key and values and that kind of stuff that you need to set in your policy in order to achieve what you're seeking to achieve. So don't expect to be an expert in security policies to be able to use this, right? Just use Google, use AWS docs to be able to find what you need. So let's just jump straight in and I'll show you how to create a security policy for S3. So here we are within our bucket, and from here we can go into permissions, and under permissions we have bucket policy. Okay, the bucket policy, written in JSON, provides access to the objects stored in the bucket. Bucket policies don't apply to objects owned by other accounts. Okay, so these are bucket policies, right? It's in the name, bucket policies. So you're gonna have to create a different policy for each bucket, right? It's not account wide. And so let's go ahead and edit. And you can click here, and this will take you to a link on Amazon, docs, just as examples for bucket policies and that kind of stuff. And and you can read through this. And like I said, this is a very complex topic, and you know, it's not the topic of this video or this section, but if you're interested in further examples, you can go on you know, you can find that link from here. But we're going to just use the policy generator. So Amazon S3, or Amazon actually has this very useful policy generator that you can use for different types of services. So you can use it for, you know, SQS, S3, VPC, IAM, and SNS. So these are all different services on AWS that require, or they don't require, but they are able to use JSON policies. And so you can generate the policies here, so you don't have to write out the JSON code, you know, or the JSON file by hand. So we're going to select policy type. We're going to select S3 bucket policy because that's what we're focused on, you know, in this section. We're working with S3, and we want to create a policy, security policy type, security policy for S3, for an S3 bucket specifically. And then we define the statements. So for this example, we're going to deny any file being uploaded into our bucket that is not encrypted using SSE S3. Okay, you know, that's a fairly straightforward example, you know, probably applicable to a lot of people. You know, if you want to basically enforce the policy that the objects being uploaded onto your bucket need to be encrypted, and not only that, they need to be encrypted, you know, using a certain type of encryption, then you know, that's an example of a very specific security policy that it wouldn't, you know, that wouldn't really make sense to have options for within the visual, right, the web console. So that's why, you know, the power of JSON comes into play, because you can define any combination, any type of policy. And so let's go ahead and do that. So by, you know, the effect is deny, because we're going to be denying file uploads for certain conditions, right? So deny. And the principle is, if you remember from the slides, the account or user to which the policy is applied. So we're just going to use a star here because this should be applied to everybody by default. I'm going to specify any certain type of user or account, and anybody who's using this bucket should have this policy applied to them. And then under actions, we can select, as you can see, there's, you know, there are a whole bunch of different actions you can select from, and you can apply policies to each of that, you know, any one of these actions. So you can take your time to go through and just familiarize yourself with the different actions that you can use in your security policies. It's quite detailed. You have control over quite a lot, but we're going to be basically using, let's find it, put object. So we're going to be denying the put object action. So, you know, putting an object into our bucket. That's what we want to apply this to. And then here we reference, using the Amazon resource name, the bucket that we want to apply this policy to. So if we go back into the S3 management console, where we clicked on policy generator, here you can see that they've conveniently provided for us the bucket ARN, because they know we're going to be using it when we're generating a policy. So we can go ahead and copy this, and we can go ahead and paste that into here. And something that you should definitely watch out for is that here we have to write /star, because these policies will be applied to the objects within the bucket. So basically we're referring to all the objects within that bucket and not the bucket itself. And so you need to refer to that using /star. Okay. And then we're going to set the conditions, right? Because if you just had this as your policy, it'll just deny everything, anybody putting any type of object without any condition. So we have to add a condition. Now, the first condition we want to add is the null condition for the AWS, or the S3X AMZ server-side encryption header when it's set to true. Okay, so essentially we're setting the condition that when this header, which determines whether or not the encryption exists or there's encryption being applied to an object or a bucket, when it's null, so when it doesn't exist, basically, we want this to trigger here. So this, denying the put object action for this, for the objects or for this bucket with this ARN. So we want that to trigger when this condition is met. So we can go ahead and add the condition, and for some reason, okay, this hadn't been properly copied, so I just went ahead and redid it, and now it's okay. So I just copy /star, and now you can see that the add statement is available. So we can go ahead and add that statement to our policy, and then we're going to be applying one more condition, and we're going to be, it's a deny condition. We're going to be applying it to everybody who's using this bucket. And again, we're going to be using the put object action. We have to find it, put object here, and the same ARN /star, and we're going to be adding a condition, and the condition is going to be, in this case, string not equals the same header, so server-side encryption, and when it's not equal to AES 256. Now this is basically the value that this header will have if the encryption type of the uploaded object is SSE S3. So essentially here, the point of this whole policy is to limit or to prevent people from uploading any objects to the bucket unless the object has SSE S3 encryption. Now you might be asking, how am I supposed to know, AES 256 means SSE S3 and so on and so forth. Again, you're not expected to know all the different possibilities of all the different ways you can write security policies with JSON, not at this level, obviously. So when you do need something, you're just going to Google it. So like, what did I do when I wanted to create this policy? I Googled, how do you, create a policy to limit object, however you search for that kind of stuff. Basically, you can be more specific, like, prevent put object for S3 for, encryption or something like that. And you'll find an AWS doc that basically walks you through it or gives you the key points, like, the values and the different headers that are used. And, after defining a couple policies on your own, right, there aren't that many headers actually. So it's going to become pretty intuitive for you to kind of experiment and figure it out. And when you do have a question about one of these, it's easy to search and find them in the docs and that kind of stuff. So anyway, let's go ahead and add this condition, add the statement. And now we have the two statements that we want in our policy, and we can go ahead and generate the policy. And you can take your time to kind of read through this and try to understand it, but there's really no need. That's the whole point of the policy generator. So let's go ahead and go into our S3 management console. Let's go ahead and paste that policy, and let's save changes. There we go. We now have a bucket policy that is supposed to prevent any uploads into the bucket of objects that are not encrypted. First of all, that's the first condition, right? That they're not encrypted, they're automatically denied. And then after that, even if they are encrypted, it'll check to see if they're SSE S3 encrypted. And if not, it'll deny those objects as well. So let's go into our permissions. Sorry, let's go into properties, and let's turn off default encryption. Disable, save changes. And let's go back into our bucket. And let's go ahead and try to upload a new version of the puppy file. And this time, right, encryption is disabled. We can go ahead and try and upload. and we see that the upload has failed. And the error is access denied. You do not have permission to upload files and folders. So the policy seems to be working, right? We're not able to upload this file or this object even because there is no encryption applied to it. So let's exit. Let's try to upload another one. Let's try to upload it this time, applying encryption to it. So upload options, enable encryption, SSE S3, okay, and upload. There we go. We were able to upload it. We received no error because the encryption of this file is, go ahead and click on it, SSE S3, server-side encryption. So there is encryption. So that's the first condition, right, that fails. And then the second condition that fails is that, it not being AES 256 or SSE S3. So because those two conditions fail, the policy fails, and then so we're able to upload this object. Now, if instead we were to upload the object, and this time, again, we encrypt it, but we encrypt it using, let's say, SSE KMS, okay? And we try to upload it, it's gonna fail again, and the same error. You do not have permission to upload files and folders because the encryption type is not SSE S3. So basically that header, or that we implemented in the policy, the S3X AMZ server-side encryption header, is not equal to the value of AES 256, which would be the value it would need to be equal to in order for the encryption to be SSE S3. Okay, so that's a very simple example of how you can implement a security policy. Again, depending on your needs, you'll just have to do some researching to find the particular headers or the particular conditions and that kind of stuff that are associated with the policy. But essentially everything else is basically the same. You have to define your resource, you deny the action, what is it that you're going to be allowing or denying, put object, get object, etc. And then the effect, right? Are you allowing or denying that action? And then the principal, which is the account or the user to which the policy should be applied to. Now, that's how you define a security policy, but there are other ways of securing your S3 buckets as well. And so, we're not going to be going into them, but if you go into permissions, for example, right, you have block public access. These are bucket settings, and these are set by default. So you can essentially edit this and determine in detail like what exactly should be blocked and so on and so forth. You could also go into ACL or access control list, and this basically determines or defines the object read writes permissions, like read write permissions at various levels. And again, this is not really important for the exam, so I'm not going to really be going into it, but you can essentially determine all of that on the bucket level. And you can also block everything on the account level. So block public access setting for account. So, even though security policies only apply to buckets, if for some reason you want to just shut off access to all your buckets, right? It's important to have that option. If something is happening, some breach is happening or whatever, and it's going to take you some time to figure out, you can just block all public access to all your buckets by default across the account. And then so remember that this is not turned on by default, but the block access for each bucket is turned on by default, and that is just generally good practice. When you're creating a bucket, you'll have the option of disabling this, but by default it will be on. And that's pretty much it for this video, which is something, if you didn't know what's possible, now you know, and it's pretty cool, pretty quirky, but it's very useful as well. And this is primarily for static websites. So you can use Amazon S3 to host a static website. On a static website, individual web pages include static content, right? So it's not dynamic, but they might also contain client-side scripts as well. But they're not dynamic in the sense that, you know, a dynamic website relies on server-side processing. So you need to have a server that's actually running. And because they have, you know, there'll be server-side scripts such as PHP, JSP, or ASP.NET, or, you know, something like that. And Amazon S3 does not support server-side scripting, but obviously, you know, there are other resources on AWS for that, like EC2 and so on and so forth. So S3, you know, it's not really a website hosting service. AWS already has services for that, but it is a file hosting service, and since static websites are essentially files, it makes sense that, you know, we should be able to use it for hosting static websites. So with that, let's go ahead and start this. I'm going to create a new bucket just for this, because, you know, we're going to be kind of playing around with some of the settings, and we just want to leave the old bucket as is for now. So let's call this bucket number 1 AWS course website. Okay. And then we just go ahead and we create this bucket. So now that we've created our bucket, let's go into our bucket. And the first thing we have to do is under properties, we got to go all the way down. And there's this section here called static website hosting, and it's currently disabled. We're going to have to enable that. So let's edit, enable, and we're going to stick with the host a static website option. And then we have to specify an index and an error document. Error document is optional, but we have to specify an index document. So this will basically be the name of the file that we want to be the index document. We haven't created our index document yet, but let's just call it index.html, and let's add an error one as well. Even though it's optional, it's good to just, you know, gracefully handle errors in any situation. So save changes. Now our bucket is now enabled for hosting a static website, and it has this endpoint here. Okay, so this means that this is basically the URL of the website until, you know, obviously you can add a domain name to it using a Route 53 or something like that. But right now, this is the URL, and this is what we can use to access the website. However, we get a 403 forbidden, you know, access denied kind of message. And the reason for that is, if you remember, by default, the permissions of a bucket are such that, you know, all public access is blocked. So we have to change that. Let's edit that. Let's uncheck this and save changes. We have to confirm, because we're basically exposing our bucket to the public. And now if you refresh this, again, it's not working. And the reason for that is we have to add a bucket policy that allows public access. Okay. So let's go in here. Let's create a bucket policy. Let's go into the policy generator. By now we're familiar with this. We're creating a bucket policy for S3. And now we're not denying anything. In fact, we want to allow all access. So the principle is everybody is allowed access. And the action now, instead of put bucket, is actually get, or instead of put object, will be get object. Okay, we're allowing everybody to get objects from this bucket here. Don't forget the /star, meaning all the objects within that bucket will have this policy applied to them. And then we can go ahead and add statement, and then we can generate policy. We don't need a condition because we're just allowing all access. It's unconditional access. And we'll just paste this into here. Save changes. Now when we refresh this, we no longer get the error, the 403 error, but we get a 404 not found. And you know, it's referring us to index.html, saying that the specified key, remember key just means object or file, it does not exist, no such key. And the reason for that is because we haven't uploaded that file yet. Now, we're going to upload that in a second here, but notice that now, like, there's a lot of red that's showing up, right? public access public. That's just, that confirms that now this bucket has public access. So that's one way to check whether or not, you were able to give public access. It's just in red because, it wants to make, AWS wants you to make sure that that there's public access to this bucket, just in case you didn't know and there's sensitive information on there. Now let's go ahead and create an index.html file so that we can actually view a page on our static website. If you don't have, you can just create a very simple HTML page, or you can just copy it from somewhere. I created one here. I'm just going to paste it in. Okay, it's very simple. My website homepage. Welcome to my website, and there's some text called now hosted on Amazon S3. So we can go ahead and save this, and I'll save it into the images folder that we've been using for the images. All files. We have the puppy, we have the burger. We're going to call this index.html. Okay. Now, when we go into here, let's refresh this just so the layout fixes itself. We can upload now the index.html file. It's here, as you can see, and we can upload it. And now when we come here and we refresh, we can see that welcome to my website, now hosted on Amazon S3. So that's very cool, right? Now this is your own bucket on your own account, and now it's a functioning static website. So currently it's very simple, but you can add any sort of HTML here, make colors and links and so on and so forth, and it's a fully functioning website that's hosted on S3 without a server. So I'd say that's pretty cool. Now let's actually create an error page. So let's delete this. Let's call this error, and then we'll just give it some colors, make it red. Nothing too fancy. And we're gonna save this as error.html. And remember, when we were back in properties for static website hosting, we defined error.html to be the error document. So whenever there's an error, we want this to show, right? So let's go ahead and, I don't know why the formatting does that, but let's go ahead and upload error.html, upload, and now let's say we did like slash some unknown page, it's going to show us error. So anytime it's not able to find the page we're looking for, it's going to direct the user directly to the error.html page. So whatever error page you have here. And one last thing we can do is we can pull up the index.html page, and we can add an image. So let's just make an image source puppy.jpg. Okay, and let's save this, and let's go back into our bucket, and we want to re-upload index.html. Upload. Now when we go to our website, there should be an image here, but we didn't upload the image yet. So we have the error.html, index.html, and now we can upload an image. And let's go ahead and upload the puppy image. And let's refresh this, and there we go. We have our puppy image, and that's it's being pulled directly from the bucket because all the files are within here. And obviously you can create a folder instead called images, and then put your images into there, and then you'd have to fix this here, you know, it would be images dot slash so on and so forth. So this is just meant to be a very quick example, but you know, it's pretty cool. You know, I myself have never had to use S3 to actually host a website, you know, but you know, I guess it's useful to know that it's possible. And that's it for this video. And it, you know, it's not so much an S3 thing as it is, you know, a web development thing. But now that we know we can host websites on S3, you know, we can avoid also going into this topic, because if you have websites, you know, you're going to eventually need cross-origin resource sharing. So I'm not going to be showing you exactly how to configure cores on a bucket, but I will kind of be going over what it is and where you can find it on the bucket page or on the bucket console, so that you could further pursue this if you are so interested. So CORE stands for cross-origin resource sharing, and it defines a way for client web applications that are loaded in one domain to interact with resources in a different domain. So if a client sends a cross-origin request, then we need to enable the correct CORS headers. And this uses XML or JSON objects to, you know, basically enable CORS for an S3 bucket. And I'm going to be showing you where to do that from, but we won't be actually creating the XML documents or the JSON, you know, files themselves. I'll just show you how to do it if you are interested in that. And CORS is a web browser-based mechanism. We can build rich client-side web applications with Amazon S3 and selectively allow cross-origin access to our Amazon S3 resources using CORS. So, you know, what are some examples or what are some scenarios of, you know, why we would ever need cross-origin resource sharing and why it even exists? So imagine, like, suppose that you are hosting a website on Amazon S3 or on an Amazon S3 bucket, just like the one we made and hosted in the last video. You know, it was called #1 Amazon course website, right? And it had an endpoint, a website endpoint that we used to access the website or to load the website, which was something like, you know, #1 Amazon course website dot s3-website dot the region, right? US East 2 dot Amazon AWS.com or something like that, right? It had a URL that we used to actually load the website endpoint. And now imagine you wanted to use JavaScript on the web pages that are stored in this bucket to be able to make authenticated GET and PUT requests against the same bucket by using the Amazon S3 API endpoint, which was, you know, #1 Amazon course website dot blah 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 .com. Now, a browser would normally block JavaScript from allowing these requests, but with CORS, you can configure your bucket to explicitly enable cross-origin requests from that same endpoint. Okay, so that's kind of the use of cross-origin resource sharing. You know, another scenario would be, you know, suppose that you want to host a web font from your S3 bucket. Again, browsers require a CORS check, which I'll show you in the next slide, and there's a little diagram I can show you. You know, this check is, you know, also called a pre-flight check, and you know, the browsers require it for loading web fonts. So you would configure the bucket that is hosting the web font to allow any origin to make these requests. Okay, so you can specify specific origins, or you can specify, you know, all origins, but essentially you have to allow that for that to take place. Okay, so let's check out this diagram here. This is essentially what's going on. You have your domain that's hosted on, you know, it has its own origin, and then you have the resource you're trying to access, which is on another origin, or it could be the same origin, but you know, the requests are happening externally, so it doesn't matter. It can be, you know, exemplified as, you know, a separate origin. And what happens is there's an initial pre-flight request that takes place before, you know, actually being able to request the resource itself, and then a pre-flight response, and this will depend on the CORS configuration. And if, you know, all this checks out, then the actual request can be performed for the resource, and then the resource will be returned to this origin here from that origin. Okay, so this is essentially what CORS is. Now, CORS, is, like I mentioned, a very, quite a complicated topic, and there's really no need to go into it any further, but it might come up on the exam for just some basic use cases, basic scenarios, and that's why, it's worth touching on. We're going to get into some, not really hands-on, but I'm going to show you exactly where you can configure cores from in the S3 console. But again, we're not going to really be configuring any cores. So let's jump right in. So here we are in our AWS S3 management console. This is the website that we created in the last video and hosted. And it's hosted in the bucket called #1 AWS Cores website. Okay. So if you want to configure this for cores, right, we'd have to go into permissions, and at the very bottom in permissions, we have a cross-origin resource sharing section, okay? And essentially, this is where you would have to configure your bucket to allow cross-origin requests, and this will be done by creating a cores configuration, which is a document with rules that identify the origins that you allow to access your bucket. So in our case, right, this is our endpoint, this is our website, this is where it's hosted at, #1 AWS Cores website .s3-website dot the region, which is US East 2.amazonaws.com. This is our website, this is our endpoint, and suppose we had a resource located on the same bucket here that we wanted access to through this endpoint, right? Currently, for example, we're accessing this image not through the endpoint, we're just referencing it directly from the folder. But suppose you wanted to access this externally through the endpoint, through a JavaScript script or something like that. The browser would, prevent that from happening, after checking to see if there's a cores configuration and discovering that there isn't one, right? So that's what we essentially have to configure here to allow for that. And so you would write your configuration to allow access to your bucket, and you can specify, for example, this origin, right, to allow access, or you can specify all origins, whatever the use case is, or whatever the scenario is. And the browser that would normally block JavaScript from allowing these requests would now allow them to happen because of this cores configuration that's explicitly enabling cross-origin requests from this endpoint here, okay? So this would essentially be pretty similar to, I guess I'm not going to go into too much detail here because this is a very niche subject and it does require some web development knowledge. And our aim with this course is to just get an overall understanding of S3, and we don't really want to spend too much time getting into individual little topics and spending too much time on them. So this should be pretty much enough for you. But yeah, if you're interested in more, just click on learn more. Also in the AWS documents for S3, under security, there's a section called using cores, and you can check out that page also for some examples. They have some examples of like different configuration files and XML or JSON files that you can use to configure like get or put or post or delete or head requests from or to an origin and that kind of stuff. So yeah, I'm going to cut this off here for now, but if you are interested, definitely look into it some more. That's it for this video. The last video in this section, and this will be a pretty quick video, no hands-on. It's more of a theoretical video, more on the theory, and it's important because you might have wondered, like, why would somebody prefer using a normal database over S3, or like what is the difference between, like, why are there even other data services on AWS and that kind of stuff? And obviously there are a lot of reasons for that, and some services are needed for big data management, and others are for for speed, and others are for like server-side computation, like for SQL querying and that kind of stuff. But it is a very good question, like when you do have applications that just require data or some sort of data structure, but they don't really require too much space, or they don't really require server-side computation. And so, I often get asked the question, like, why not S3 for everything? Is S3 like the magical solution where you can just, zip up a database and just store it there and then pull it in for your web app or whatever, whenever you need to, and that kind of stuff? And so in order to understand the trade-offs, basically, for when to use S3 and what you're sacrificing and what you're gaining and that kind of stuff, it's always good to look at the data consistency model of the data service you're utilizing. So in the case of S3, there are some trade-offs, right? There are some things that you're gaining, and there are some things that you are sacrificing on when you're using S3. So let's look at those. First of all, right, you have a very strong read after write consistency for puts and deletes of objects in your Amazon S3 bucket in all AWS regions. Okay, so, and then you also have high availability for replicating data across multiple servers within an AWS data center. So you definitely gain from the availability aspect compared to some other data services you might be using. The fact that you have high availability, it's 99.99% available. There's really no chance of you losing your data on S3. Now, however, when it comes to actual consistency, bucket configurations have what's known as an eventually consistent model. And that means that, for example, right, if you delete a bucket and immediately list all buckets, okay, deleted bucket might still appear in the list. Okay, and so it's eventually consistent. It's not immediately consistent. And so if that's something that's important for your application or for your particular use case, you have to be careful about using S3. You might want to use another type of service, or you might want to modify the logic of your code or how you utilize S3 in order to avoid any pitfalls from this. Now, note that this is for buckets. Objects do have a strong read after write consistency for puts and deletes, but for buckets, you have this eventually consistent model. So if you enable versioning on a bucket for the first time, it might take a short time for the change to be fully propagated. So this is also another one of those things where, like, if you had an actual database, it would be immediate, right? Because a database has its own server, and like basically you're paying for that server. It's your server, so you have direct access, immediate access to it. Whereas with S3, you're not paying for the servers, right? AWS is paying for the servers. They're dealing with that in the back end. They're dealing with figuring out how and where to store your changes and your updates and that kind of stuff. So it might take some time for them to allocate stuff in such a way as to optimize the pricing and everything for them on their end. And so that's completely expected and understandable. So it is recommended that you wait for 15 minutes after enabling versioning before issuing write operations, which are basically put or delete operations on objects in the bucket. Okay, and so that's a trade-off that you should be able to live with if you're going to be using S3, especially for the other stuff you gain instead of that, right? Like by giving that up. Now, that's it. Again, if your application is like highly critical and you believe that it's unique in the way that it uses data and leverages your data storage and that kind of stuff, and you just want to be extra sure, you just look up the S3 data consistency model on AWS, and just to look into a little bit more of the different caveats or other little ways that S3 kind of works, so as to make sure that you're not going to run into any issues. But overall, right, it shouldn't be that much of a problem. Like, especially if if you have concurrent read and write operations, like with concurrent operations, with concurrent applications, you might want to watch out for some of the behavior of how the reading and writing happens, right? Because that's something else that's a big advantage of using an actual database, is that it deals with concurrent read and writes, whereas with S3 you might have some issues if an application is reading and writing the same data at the same time. It's nothing that's not solvable, but it's just something to watch out for, right? S3 is not really intended to be used as a database. It's just a data storage, object storage, not even data storage, an object storage service. So if you are going to be using it as a database, do be careful about it and do your due diligence and make sure that everything's going to be all right. Okay, that's it for this section. I will see you in the next one. In this section, we're going to be going over AWS CLI, or AWS Command Line Interface. And generally, people might introduce this topic later on, after a couple more of the fundamental concepts of AWS have uncovered. But I'm choosing to introduce it in this section because the earlier you get your hands on the CLI, the better it'll be for you, because the real power of AWS lies in being able to utilize the CLI and the SDK and the public APIs for the various AWS services. So, and that's what's going to set you apart from the commoners out there who just are using AWS but don't really know anything about it, is that you're going to be able to basically manipulate and work with any of the AWS resources or services directly from the command line or from your coding environment, your programming environment, using the SDK. So it's important that at least, at the very least, we know how to set it up and we know how to run commands on it. Even if, in this course, we're not going to be going into actual development and actual automation, as that's outside the scope of this course, at least you're going to have the tools ready for you and available to you to take that path if you choose to do so. And I would suggest that you choose to do so, as soon as possible. The sooner the better. So when we're talking about the AWS CLI, we're also referring to the SDK and the API. So essentially behind the CLI is access to the APIs that the services provide for you. But let's first define what the CLI is, right? I'm sure you've heard of it, but it doesn't hurt to define it. So it's an open source tool that enables you to interact with AWS services using commands in your command line shell. And you might, say, what's the point of this? Trust me, this is incredibly powerful. This is where the true power of AWS lies. So even if you are not able to grasp that as of yet, just take my word for it and invest your time and resources into mastering the CLI. So it provides direct access to the public APIs of AWS services. So all these services that we've been learning about, everything from IAM to S3 to EC2, plus everything else we're going to be learning about, has public APIs that you can use to control those services or those resources. The CLI is basically giving you access to those APIs through a command line interface. Okay, so what's really being done is, everything's been converted into API requests on the back end. And that's why, when I say CLI, I'm also referring to SDK, because the SDK does the same thing. It also gives you direct access to the public APIs of AWS services in the back end, but it gives you a coding or programming front end to do so. So we're not going to be covering the SDK in this course, but it's essentially the same thing. It's going to be the same control you have over the AWS services and resources, except the environment is going to be different. In the case of CLI, it's just directly from your command line shell. In the case of an SDK, it'll be from your programming environment, whether it be Python or C++ or whatever, right? And basically, you're able to communicate with AWS resources and services using a command line interface. And that allows you to manage all AWS services and control them. And it allows you to automate AWS infrastructure, resource, and service management. And that's because essentially everything that you would normally do using, you know, a click and drop interface on the AWS console, you'll be doing by sending commands which are written, right? So this means you could potentially compile these commands into a file, like a bash script or something, and run them, you know, and then basically program some sort of sequence in which, you know, different commands are run and different resources are allocated, different services are configured, so on and so forth on AWS based on, you know, your code and that kind of stuff. So basically you're automating everything, right? And there's going to be a lot of examples for that. You know, this is not a developer course, right? This is a solution architect course. So we won't be relying too much on the CLI, but essentially, you know, if you do choose to be an AWS developer, this is something you'll have to master. And even if you don't, I would highly recommend it. So all IaaS, infrastructure as a service, AWS administration management, and access functions in the AWS Management Console are available in the AWS API and CLI, okay? Now, when new services become available or new features get released by AWS, they will either immediately have access through the API or 180 days after launch, right? And by the way, so when I'm saying API, you know, I mean CLI, I mean SDK, it's all, because, you know, all of it relies on the APIs of the services, right? The fact that each service has an API that you can use to manipulate it, or to configure it or to use it or whatever, and the CLI and the SDK are both using APIs in the backend, right? They're using the same APIs. It's just the front end interface is different if it's an SDK or the CLI. So don't get confused if I use them interchangeably, but you know, in this course and specifically in this section, we're focusing on the CLI, and I'm going to be showing you how to set the CLI up for Windows, Mac OS, and Linux. But I myself will be using Linux to use the AWS console. But once you have, or the AWS CLI, but once you have it installed on Mac OS or Windows or Linux, it's going to be the same, basically the same commands, same functions, right? And I'm going to show you exactly how to do all of that. And then I'm going to also be showing you how to set it up on an EC2 instance as well, because you might want programmatic access to AWS services through an EC2 instance, right? For some more complex architecture, right? Maybe you want your EC2 instance to basically initiate the formation of different services and that kind of stuff. And, you know, it's part of your larger infrastructure or your larger application or whatever. So, but there's a special way to go about doing that using IAM roles. And so I'm going to be showing you all of that in this section. So that concludes the introduction, and let's jump right into the next video. Thanks. Bye-bye. The AWS CLI for Windows, Mac OS, and Linux. I've put all of this into one single video because it's pretty quick for all of them. You know, there's no long process. In fact, it's so easy that I probably didn't even need to record this video, but I just want to be thorough. So you can skip ahead to whichever OS you're using, or you can just stick through this whole video just so you can learn how to do it, especially if you're working in an environment where you're not really sure if you're going to be needing to install this on Windows or Mac OS or Linux. So, you know, it doesn't hurt, obviously. We're starting with Windows, and we're going to be ending with Linux because I'm going to be actually using Linux myself. And I'll have hands-on for both the Windows and the Linux parts of this video, but not for the Mac OS because I do not own a Mac and I do not want to own a Mac. And I, you know, frankly, you know, there's no need. You know, if it was a long, complex process, then, you know, I would have sought out a friend with a Mac or something like that. But at any stage throughout this video, if you do encounter problems installing the CLI, just search for the AWS documentation on how to install AWS CLI. It's very thoroughly documented. You shouldn't have any problems. Keep in mind, we will be using AWS CLI version 2, not version 1. As of recording this video, there's only one, and versions 1 and 2. We'll be using version 2 only. And with that, let's get started with how to install the AWS CLI on a Windows system. Just some very quick prerequisites. You should have a 64-bit version of Windows XP or later. So, if you don't, you're kind of out of luck. But yeah, so that's just a prerequisite. And then you should have admin rights to install software, right? If you're, a college student, you're using the laboratory at school or something like that, the computer lab, it might not work. So you do need to contact whoever does have admin rights to let you install the CLI. So with that, you will download the latest AWS CLI MSI installer for Windows, 64-bit. And the link for that is right here. You can just type that in. It's very easy. awscli.amazonaws.com/AWS CLI v2 in capital letters .msi. So this will download the latest version, meaning if by the time you're watching this video, there is another version out, then, the version I'm using here, it's going to download that. So there are ways you can specify in the URL which version specifically you want to install or to download. And if you're interested in that, just go look up the documentation on AWS and they'll show you how to do that. Now, once you download it, you will run the downloaded MSI installer and follow the on-screen instructions. I will be walking you through all of this shortly. So by default, the AWS CLI installs to program files Amazon AWS CLI v2. Okay, and you can change that while installing, but I don't see any reason that you would need to. So we're just going to stick with the default. And to confirm the installation, you will open the start menu, search for CMD, which is the command prompt, right? And open up the command prompt window. And at the command prompt, use the command AWS -- version. So I'm going to be showing you this as well. Essentially, this is the output you're looking for, or something along these lines. It might not be 2.1.24, it might be 2.2. Whatever, right? And then the Python version might be different, and so on and so forth. But essentially, you want there to be some sort of output here to confirm that AWS CLI has been downloaded. If you get some sort of error or command not found or something like that, that means that something went wrong in the process. So you'll have to troubleshoot on your own. Just look through the documentation on AWS. It shouldn't be too much of a problem. Essentially, all the commands we're going to be running on the AWS CLI will be run using AWS, right? And then we would specify either the tags, which are the options, or additional commands. So we're going to be learning about that later on in this section. So that's it for installing Windows. Let's jump into the hands-on, where I will actually do all of this for you so you can see it and you can follow along with me as well. So here we are in the browser. I have my Chrome browser open, and I just happen to be on AWS's homepage, but I've pasted the URL to the .msi installer, the one that you need in order to install the Amazon CLI onto your Windows computer. So when I press enter here, it's going to go ahead and download. Now keep in mind that we are using AWS CLI version 2 and not version 1. You should also be using version 2. There's no reason for you to use version 1, especially if you're following along with me. Maybe by the time you're watching this video, there might be a third version or something. I don't know, but just know that I'm using version 2. And there we go. The installer has downloaded. Let's go ahead and click it to launch it. And once it launches, let's just give it some time. There we go. Now it's actually completely finished installing. So now we can click it and it will launch, preparing to install. We're just going to go with the defaults for everything. I do accept. Just go next and install. And we're going to need to give it permission. And it's installing. So it's a pretty quick process. There shouldn't really be any complications. If you do encounter any issues, just go ahead and just search AWS CLI, for Windows, how to, or something like that. And AWS has some very thorough documentation on any of the different issues that you might encounter when trying to install AWS CLI onto your Windows machine. And there we go, that's it. Click finish. And now if we open up the command line like so, we have access to, we can check if AWS was properly installed by typing in AWS / version. And there we go. We do in fact have AWS CLI version 2.1.27 installed, and it's using Python 3.7.9 in the backend to actually access the API, the various AWS APIs. So this is working, like a charm. You can now use any of the AWS or CLI commands from the terminal. We're going to be getting into those later on in this section, but that's it. It's nice and quick. That's how you install AWS CLI for Windows. So we just installed the AWS CLI on Windows. Now I'm going to be quickly showing you how to do it on Mac OS. However, there will not be a hands-on section to this part of the video, as I mentioned in the beginning of the video. So let's just go right in. The prerequisites are that you have an Apple supported version of 64-bit Mac OS, and that's pretty much it. So the first thing you'll do is you'll go into your browser and download the PKG file of the latest version of the AWS CLI. Again, that will be version 2, and this is where you can find it, just like we did in the Windows section of the video. And then you double click on the downloaded file to launch the installer. Follow the on-screen instructions. You can install to any folder, but if you just go with the defaults, which I recommend, just so you don't mess anything up, it will choose the default folder of /user/local/AWS-CLI. And by default, this will install for all users. And if you do want to install for only the current user, you can just look up the documentation on AWS, and you can do that as well. And then to verify that the shell can find and run the AWS command in your path, you will use the following command. So you can just type which AWS, and that'll show you its location. And then you can type in AWS -- version, and you should get an output like this, something similar to that. And if you do, again, get something like command not found, or error or something like that, that means you did something wrong in one of these steps. So just try to redo it. If not, troubleshoot using the AWS documentation. So that's pretty much it. Just as easy, just as straightforward as installing on Windows. Now let's see how we can do this for Linux. And finally, let us learn how to install the AWS CLI on a Linux system. This is also very straightforward, and generally, as you probably know, it's easier to install stuff on Linux anyway. So it's best saved for last. And again, let me remind you that I will be using a Linux system for my AWS CLI for the duration of this course, even though I do have a PC. But I'm going to be choosing to use an AWS CLI for this course. So prerequisites, you must be able to extract or unzip the downloaded package. If your operating system doesn't have a built-in unzip command, use an equivalent, okay? The AWS CLI version 2 uses glibc, groff, and less. These are included by default in most major distributions of Linux, so you shouldn't have a problem. I'm going to be installing the AWS CLI on an Ubuntu 20 kernel, so that's not going to be a problem. And 64-bit versions of recent distributions of CentOS, Fedora, Ubuntu, and the Amazon Linux distributions as well are what are compatible with AWS CLI. So just make sure you have one of these, otherwise you might have some problems. And you can also install the AWS CLI on 64-bit Linux ARM, which I will not be showing you how to do, but it's going to be pretty similar just the installer, the link for the installer is going to be different. So you'll have to look that up as well. Again, just use AWS documentation. They have it, everything very clearly explained and presented there. So the first thing you're going to do is in the terminal, you're going to run curl and then this link. So this is essentially pretty much, the same way we installed for Mac OS and Windows. It's just a link that has an installer. In this case, it's zipped, and we're using curl to just fetch that from the URL in the terminal. So you're going to do this in the terminal, and we're going to save it to AWS CLI v2.zip, and then we're going to unzip it like so, and then just run sudo./AWS/install, and that will basically initiate the installment or the installation, and then that's pretty much it, and you're ready to go. So let's jump straight into a terminal and do that ourselves. So here we are in an Ubuntu terminal, and we can just go ahead and just check very quickly to see if AWS is installed, and we can see that it has not been installed. And we're going to go ahead and first download the installer, which will be a zip, which will be in the form of a zip file, and we're going to save it into AWS CLI v2. Let's go ahead and do that. So it's downloading the installer for the CLI for Linux, and let's just let it do that. It shouldn't take too long. There we go. And then we can go ahead and unzip AWS CLI v2.zip. We're unzipping it. Again, you need to have, you need to be able to extract or unzip the downloaded package. So if you don't have unzip, you can have, you can use something else as well, or just install unzip. And then finally, we're going to run the installer, sudo./AWS/install. And there we go. We should have it installed. And how do we check? Let's go ahead and clear. How do we check? AWS -version, and there we go. We have AWS CLI 2.1.27 installed using Python 3.7.3, etc., etc. Okay, so that's how you install the AWS CLI on a Linux system. And in the next video, I'm going to be showing you how we can now configure this so that we can start using it, right? Because right now, the CLI is installed on all of our systems, but it doesn't know which account we want to access, and that kind of stuff. So we're going to be configuring all of that in the next video, configuring the AWS CLI. So this is where things start to get a little bit more fun. Things start to pick up, and we start actually interacting with the AWS CLI, even though we're not really directly interacting with any of the AWS services as of yet. That's when things are going to get really fun. But before we can do that, we have to configure the CLI so that it knows who we are and which account we're trying to access and which region, etc. So it's worth noting that all incoming requests are cryptographically signed when using AWS CLI. So don't worry about that. Don't worry about your access key or secret access key or whatever, like being exposed, as it's traveling back and forth between your personal computer and the AWS servers or something like that. So, just wanted to make a note of that. And essentially the AWS configure command. So remember, before any command that we want to issue with AWS CLI, we're going to, prefix AWS to it. So that's going to basically specify that we're using the AWS CLI, and then we're going to put in the command. So the command would be AWS configure, as I'm going to be showing you, is the fastest way to set up your AWS CLI installation. So there are other ways, but this is the fastest way, and it's a way that you have to definitely know. And it will ask for the following. It will ask for an AWS access key ID, which I'll show you how to find from the AWS console, and it'll ask for an AWS secret access key. Those two go hand in hand, so it's going to be a pair. And then it's going to ask for default region name. So you can leave it blank, but you should just enter in your default region, right? The region that you use most of your services on. That's going to be the region that you're in or closest to. And then default output format, which doesn't concern us for this course. So we're just going to leave that blank. Okay. So let's jump straight into the AWS command line interface and start configuring it. So here we are in our terminal. So this will be my Ubuntu terminal. For you, it could be your Windows command prompt or your Mac OS terminal. It doesn't matter, because we all have AWS CLI version 2 installed, and we can go ahead and check that by just which AWS. For me, it's user local bin AWS, and then AWS version. There we go. Now we're gonna configure AWS. So let's go ahead and write configure like so. This is the command. So AWS is specifying that we're using AWS CLI, and configure is the command that we're specifically referring to within the CLI. So it's asking us for an AWS access key ID. Okay, let's just just to walk through it, I'm gonna just leave it blank, just so you can see. So it's gonna ask for the access key ID, secret access key. So it's telling me that none has been specified so far. None has been specified. The default region name, which is also hasn't been specified, and then the default output format, and then we press enter, and there we go. So here we are in the AWS management console, which we will actually be needing to find our access key and secret access key so that we can configure our AWS CLI, after which we will no longer need the AWS management console because we'll be able to do everything directly from the terminal, from the command line interface. So let's just go into AIM, and in AIM, let's find our user. So under users, this isn't the user I had created for myself. We actually created this together in the second section of this course. So we can go ahead and click on it. And here we have a tab called Security Credentials. So go ahead and click on that. And here we have the page where we have all the information related to our keys, access keys, sign-in credentials, and so on and so forth. So we want to focus on this section here, access keys. Use access keys to make programmatic calls to AWS from the AWS CLI, or tools for PowerShell, or AWS SDKs, or direct AWS API calls. So again, remember, we're using CLI, SDK, and API just interchangeably, but essentially they're all using the AWS API calls. And you can have a maximum of 2 access keys, active or inactive, at a single time. Now, before we do this, I have to emphasize how important it is that you keep your access keys secret. Okay, they are equivalent to your root password, username and password for your account. Anybody who has access to your access keys can do whatever they want on your account, right? So they can go and they can just launch a million EC2 instances if they want to, and then you'll get a bill for thousands and thousands of dollars, right? So you have to be very careful. Be very careful where you store your access keys. Be very careful who sees them. Actually, nobody should see them. So you should never ever have to share your access key with anybody. There are other ways, to achieve what you want to achieve by doing that, right? If you want to give somebody access to your account, you can make them a user. You can assign a role to them, or whatever service they're trying to use to access your account, or there are many other ways to do it. Never share your access keys. These access keys are for you. They're for you and only. Okay, so that's something I have to really emphasize. Security is paramount, especially when you're dealing with clients and you're dealing with their accounts. You have to be extra careful, because you might be saying, nobody wants to steal my access key, but you don't know about your clients, right? What if they get hacked? Or what if you get hacked and now everybody, has access to all your clients' access keys or something, right? So it's very important. Security is very important because it will cost you a lot of money. Forget reputation, forget all of that, embarrassment. Just the cost, the financial cost of it will be enormous. People, there are genuine trolls out there. If they do get your access key, they'll just go and try to spawn as many instances and services as possible, just so they can end up costing you. And they just they gain benefit from something like that. They see it as fun. So you got to really be careful. And if you lose or forget your secret access keys, you cannot retrieve it. Instead, create a new access key and make the old key inactive. So if something does happen like that, if there is a breach, or you do fear that somebody might have access or access key or something like that, you can come in here and delete it, and I'll show you how to do that right now. So the first thing we want to do is actually create an access key. So we click create access key. Now I'm going to be deleting this before the video launches, so it's okay for you to see it. Okay, you're not going to be able to use this by the time this video launches, but don't get into the habit of doing this. Don't show people your access keys. Okay, so you can download it as a CSV file, just like we downloaded our the keys before, or you can just access it directly from here. But once you close this window, right, once you close it, it's gone. You have the access key, but you don't have the secret access key. Okay, there's no way to find it anymore. We didn't download it and we didn't copy it, so this right now is useless for us. We can't use it. So the only thing we can do is we can make it inactive, deactivate, and delete it. So to delete it, we're just gonna do it like so, and there we go. Now we can create a new access key, and it'll generate a new one for us. So we can download it and access it like this, or we can just copy and paste it from here, because I'm just going to be using this for this video. It's okay that we don't download it, but what we're going to be doing is, now that we have the access key ID and the secret access key, we can go into our terminal and we can configure our command line interface. So for the access key, let's go ahead and copy this. And for the secret access key, again, let's copy this. And for the default region name, I'm in US East 2, and we're going to leave this blank. There we go. We have configured the AWS CLI, and there are a couple ways we can check if that worked or not. The first would be to just run AWS configure again. And there we go. We can see that we have a specified, we have already specified an access key ID, and it's ending in DC5B, and that's correct. And if we just keep going, we'll see that we also have a secret access key for it, and the default region is US East-2, and we have not specified a default output format. So we have successfully configured AWS CLI. Another way to check for that would be to check where AWS actually stores the credentials and the configuration. So that would be for my, I'm using a Linux system, so it would be within AWS, my bad. So within .aws, there will be, so, if you go into your root folder, you'll see AWS here. And then if you just print out everything that's in that folder, you'll see that there are two folders, config and credentials. So the configuration details will be stored in config, and the credentials will be stored in credentials. And we can print out each of them just to see what's there. So we can see that, the configuration, the only thing we've configured so far has been the region, which we've configured to be US-East-2. So that's for the default profile. We can create multiple profiles as well, and then you can see for each profile what you've configured. Now let's also print out the details of the credentials folder file, and then here we can see that we can actually see our access key ID and our secret access key. So this is very good that you can see this right now. Why? Because it should reinforce the fact that you should never be using your access key ID and your secret access key on any other device other than your own personal computer. Why? Because once you've configured any AWS CLI to your account, essentially your secret access key and your access key ID are being saved openly onto that device, right? So if this was, if I had done all of this in an EC2 instance, which is not secure, which is not a device that I own, it's not my own device, right? It's AWS's device. If somebody were to access that instance, they would be able to see my access key ID and the secret access key, and then they can take this and they can use this to configure their own computer to my account, and then they can do whatever they want. They could just wreak havoc, right? So this is, very important to reinforce what I've been saying. Only use these credentials on your own personal computer, okay? Now, that's pretty much it. We've configured AWS CLI. We can now start using the AWS CLI. We're going to be doing that in the next video, a couple of videos, not the next video, but the one after. But just to show you that it actually works, we can do like AWS S3 LS. So we're using the S3 API directly, and we're listing out the buckets we have. And remember, we had the #1 AWS course bucket, and then we had the #1 AWS course website bucket. And we're able to see this directly on our computer, directly from the command line interface. And we're accessing our S3 service on our AWS account. So that's really cool, right? That should just amaze you, right? The first time, I discovered the power of the AWS CLI, I was amazed. So that's just a little taste as to what we can do. Obviously, we're going to be doing some more later on and throughout the course. And that was my intention for introducing you to the AWS CLI from the very beginning, so that, occasionally I can show you how to do some of the stuff we're learning on the AWS CLI as well. And so you're not just stuck learning how to do everything on the console, but learn how to do it, programmatically as well. So this is pretty much how you can configure AWS CLI for your Mac OS, Windows, Linux, or any other device that you have AWS CLI installed on. But when it comes to configuring AWS CLI on an EC2 instance, because now it's not going to be a device that you yourself own, it's going to be slightly different. So we're starting off this video with another reminder, being careful when it comes to your credentials, okay? So never run AWS configure on an EC2 instance. Now, obviously you can, right? EC2 is essentially just another computer. If you're using, let's say, Amazon Linux 2 for the image, then you just follow the steps we outlined in the slides, and you should be able to download and install Amazon AWS CLI and start using it and configure it how we configured it in the last video. However, this will be ill-advised and definitely not recommended. And the reason for that is because, like we saw in the last video, as soon as you configure that device using your credentials are openly saved onto that device. That means that anybody who has access to that device can easily access your credentials and see them completely exposed without any issues, just like that. And then they'll be able to use it wherever they want to, right? So since an EC2 instance is not something that we own, it's not our personal computer, right? We're just using it temporarily. We're renting it out, basically. It's not good, because anyone who has access or gains access to the EC2 machine will have access to your credentials. So only use your credentials on personal computers that belong to you. Now, in that case, you might ask me, how do you configure an AWS CLI on an EC2 instance? And we do that using IAM roles. If you remember, in the IAM section of this course, we talked about users and we talked about policies and giving different users access to different services and limiting access and function to certain functionalities and so on and so forth using users and roles. And we didn't really go into roles too much, but I mentioned to you that roles are basically the same thing as users, right? But they're intended to be used for actual AWS services. So granting access to different services for other services. For example, if you want to grant access to your EC2 instance, you want to give it access to, let's say, your S3 buckets, or to another EC2 instance, or just give it the ability to create other EC2 instances, or to use any of the other AWS services. You're going to essentially need to configure the instance to be able to use AWS CLI, and you're going to have to give it access to these services. And it's not really a user per se, right? It's just a service. So you're going to, in that case, define what are called roles, and they do act in pretty much the same way that users act. They can also be assigned policies and so on and so forth, but they're intended to be used by other services on AWS. So I'm going to be showing you how to do that, so don't worry about how much you understood that slide. So let's jump right into EC2 CLI configuration, roles, and policies. Now here we are where we left off in the last video, and as you can see, I've deleted my access key because I had shown you guys access key as well. So I deleted that, but we're not going to be needing that, right? Because we're going to be configuring an EC2 instance, and I told you we can do that without actually using access keys. So let's go into EC2. Last we had terminated all our instances, so let's very quickly create a new instance or launch a new instance. It'll be a refresher for us. So let's go ahead and launch an instance. We're going to just use Amazon Linux 2, and we're going to be using the T2 micro free tier instance type. And let's just review and launch. We don't really need to deal with any of the details. And we're going to be using the same key pair. And we can view our instance. So we can just connect directly with the instance, right? Obviously it's got to initiate, right? It's got to get started up, but essentially we can connect to it. And it's a Linux instance. So we can just download the installer for Amazon CLI, install it, and configure it. But we're not going to be doing that. Instead, we're going to be assigning it an IAM role, and that IAM role will have access to essentially, any particular service in AWS. So if we go down into details, okay, we can see that many of the details around the instance, but what we're looking for is in security. We can see that there is no IAM role assigned to this instance, so it's currently blank. Okay, so now that it's running, let's open it up. Okay, and I'll have these side by side so we can see both. So we have our instance here, okay, and because we used an Amazon Linux 2 image, Amazon actually conveniently installs the AWS CLI for us, and so we don't have to install it. So we have it installed, and it's not version 2, but that's okay, right? So it's installed, and we can see if it's configured. And we can see that it's not configured. And again, do not use this method to configure an EC2 instance. And we can just see if, let's say, S3 ls unable to locate credentials because we haven't configured it. And you can configure credentials by running AWS configure, but that's not what we're going to do. Instead, we're going to come back in here, and we're going to note that there is no IAM role assigned to this instance, and currently we are not configured. And then we're going to go into IAM in a separate tab and go into roles, and we're going to create a new role. Okay, now roles like I said, are basically users, but for different services. So you can actually assign roles or create roles to assign to any of the AWS services. So like, let's say you want to have, you want to assign, let's say, a role to EC2 to access S3, or you want to assign it to, I don't know, RDS to be accessed by, EKS, and so on and so forth, right? And so you want to really define all of the you have to really fine tune all of the different permissions and so on and so forth. And you'll do that from here. So we're going to select the type of trusted entity. Now you can also assign roles to AWS accounts and web entities and so on and so forth, but that's a more advanced topic. We're going to be sticking with AWS Services, and the two most common are Lambda and EC2, but you can also select any of the other ones. We're going to be selecting EC2. Okay, now when we go into permissions, this is where we will be creating our policy or assigning an existing policy. If you remember, this is exactly the same way we created our own accounts, right? When I was creating my account, I assigned it the administrator access policy, right? And you can view the details of it by opening it up and essentially seeing what you have access to, right? And you can do this for any of the predefined. So here we have access to 270 out of 270 services. But we don't want to do that, right? We don't want to give our instance complete access to everything. So instead, we're going to create a policy. And so again, you can pick a predefined policy if you find one to your liking. For example, if you go into S3, Amazon S3, there's Amazon S3 full access. There's Amazon S3 read-only access, right? So on and so forth. But we can also create our own. So starting off, let's actually use the Amazon S3 read-only access. Okay, let's click on that. But let's also see what's in there. And you can see that it only has limited read access. Okay, and for more information, we can view it as a JSON, and we can see that it allows the get and the list calls, any type of get call, any type of list call, okay, for all resources. So potentially, if we wanted to modify this, right, we could just copy it. We could copy it, and then we can change some of this, and we can paste it into a new policy, right? Or when we're creating a policy, we can choose a service, and we can select S3 from here. So we can allow all S3 actions, or we can just pick one of these access levels. So let's say read, and we selected 43 read commands, and we can selectively, like, we can say that we don't want to select all of them. We just want to give it permission to get an object, let's say, okay, or we just want to give it permission to get bucket tagging or something like that, right? Whatever it is, you can basically fine tune it here. Let's just click on read all for now, and then you can select the AWS the resource that you want to basically allow it to access. So you can any access point, any bucket, any job, blah blah blah, or you can add an ARN. So for a bucket name, you could specify specifically which bucket to access by the ARN, so on and so forth. So you can configure any number, to any level of detail in the policy generator. But for our sake, currently, let's just stick with the read only, Amazon S3 read only access policy. Okay, and let's go to next. We don't really want to do tags right now, and then we can give this a name. My EC2 S3 policy test. Okay, allow EC2 instances to call AWS services on your behalf. Allow AWS instances to read and get S3. Okay, and then we create the role. Now we can see that aside from the AWS managed roles, we have my EC2 S3 policy test. Okay, this is a policy that we have created and that we are managing ourselves. Okay, but it just so happens to have the Amazon S3 read-only access policy attached to it. Oh, my bad. This is a role that we created, and within it, it has this policy attached to it. So at any point in time, even if this role is assigned to a particular EC2 instance or multiple EC2 instances, or to other services as well, we can come in here and we can change the policies. So we can add or remove, and we can edit, and we could change the policies. So all of that will propagate to any service that has this role. So now that we've created that role, let's go back into our EC2 instances, our EC2 dashboard, and let us go into actions, security, modify IAM role. So we've selected the instance we just created. We want to modify the IAM role, and from here we can select the roles we want. We could also create a new IAM role directly from here as well. That's also something that's very useful. But for now, we just want to use the one we just created, and we're going to save it. And now when you go into security, you should see, you should probably refresh. There we go. We have a role assigned to this instance. Now, if we go back into our instance here, and we try to do AWS, we have to refresh because it's timed out. We haven't used it for a while. Let's refresh, but it's essentially the same instance. You can see from the ID. There we go. You can see from the ID that it's the same instance. Now when we go into AWS, let's say S3LS, we can now fetch our bucket items. We can see the bucket, the S3, the buckets, and we can even read the individual objects if we wanted to. And to do that, we would AWS LS S3, let's say number 1 AWS course. Oh, we forgot to put 2 slashes. And there we go. We only have puppy.jpg, and then we can do the AWS number 1 AWS course website bucket, and we can also see that we have the air.html, index.html, puppy.jpg object within that bucket. So both of these commands, right, they fall into reading S3, reading and fetching S3, and we have complete read access to S3 because of the role. And so we're able to use, we're able to access our S3 through the EC2. So essentially we've configured the EC2 instance without actually using any credentials. So this is the proper way to configure an EC2 instance. Okay, that's pretty cool. Now, if we wanted to limit, let's say something, we want to limit access. Let's say we want to attach a policy, okay, and we want to create a policy, and we want to choose service S3, and we want to only give it read access, but we don't want to give it access to everything. We want to give it access to get, we don't want to give it access to get object, but we want to give it access to, let's see, let's give it access to everything, okay, except the objects. We don't want to give access to anything to do with objects. So, okay, I think that should be enough, right? We don't want to give it access to the get object. Grants permission to retrieve objects from S3. Yeah, so we don't want to give it access to that. All resources, right? Let's just do all resources, and then next, review, no get object only read bucket. Let's say, okay, get object prevented. Okay, so we have limited read access, create policy, and there we go. We have these AWS managed policies here, and then we have a customer managed policy that we just created, and we can go ahead and select that. We can go ahead and go back into roles, or so that's in policies. Let's go back into here, and now when we write no, let's refresh. Now we have this here, no get object only read bucket, and we're attaching this policy. Now that it's attached, we can go ahead and try to do this again. Sometimes it takes time to propagate, but let's also do something just in case. Let's deattach this policy. And there we go. We are getting an error. So sometimes it takes time to propagate across all of AWS's infrastructure. So just make note of that. Like when you just assign a new policy, it might not be instant. So if you're relying on instantaneous propagation of assigned policies, then you can't, basically. Okay, so anyway, as you can see now, we have an error occurred, access denied when calling the list object v2 operation, access denied. That's basically how you configure an EC2 instance, and how you can assign policies, and how you can assign roles, and so on and so forth. So assigning roles is something that's very important, and that you're going to be using a lot for many of the services, because a lot of the services will need access to other services. And roles are basically how you give them access, and you grant permission, and you manage all of that. So sometimes it kind of gets confusing with all the policies. It's hard to keep track exactly what each policy does. So you can use something called the AWS Policy Simulator, and that's located at policysim.aws.amazon.com. And from here, so this is something that, this is from AWS themselves. So since I'm logged in with my account, I can see my users, and I can see my roles as well. So from the roles, if I go into policy simulator, I go into policies, I can see my policy here. Okay, the policy that I defined, and then I can actually run simulation. So let's select S3, and then we are allowed to get access point, right? Because somewhere here, yeah, there we go. Get access point has been allowed. Allow, you see, for all resources, right? But let's say we want to get object, okay, and we want to run the simulation. We can see that's denied. Okay, so this is very useful. Any policy you have, you don't have to actually go and try it all out. You just come into here, and you just find your policy from your role and the service, and you just simulate basically, and you can figure out exactly what this policy gives you access to, and what it blocks or prevents. So this is a very useful tool to really use, especially when you're writing your own policies, or using policies that other people pass along to you, so you can really check if everything, all the functionality you want is present and working. And yeah, so that's pretty much it. We went over how to configure an EC2 instance to the AWS CLI, and we did that without even using AWS Configure. We did that by creating a role, and then giving access to whatever we want to give EC2 access to from that role as a policy, and then assigning that role to an EC2 instance. And then right away we were able to start using the different services on AWS through the CLI on EC2, and we didn't have to even install it or download it because it came with the Amazon Linux 2 distribution. And then from there, I showed you briefly how you can create your own policy, and then the policy simulator. So we learned how to create roles and policies, and we learned about the policy simulator. So I hope that was an informative video. That's pretty much it for configuration. Now in the next videos, we're going to just very lightly be interacting with some of the services on AWS, just the services that we've learned so far. So like EC2, S3, IAM, and then in the future videos, as we learn new services, I might occasionally, pull up the CLI and just show you some more stuff. But the CLI is a vast, it's as vast as AWS itself, because you can control everything from there. So it's going to kind of be up to you to continue your learning journey after this section. Configuration, we now have complete control over AWS CLI and over all of AWS's services and their public APIs. So what can we do with this? Basically anything we want. We can do everything we can that we could do in the AWS console, the web console, plus more, because sometimes essentially the AWS Web Console also utilizes the APIs in the backend to call the services, and not all the functionality is always present in the Web Console. But with the CLI, you have complete access to the whole, all the features of all the APIs. So you actually have more control than you would on the Web Console, even though the Web Console keeps getting improved and more options are added with every passing day, but it'll never reach the full capacity of what you can do with the AWS CLI. So in this video, since this section isn't really intended to be a deep dive into AWS CLI in terms of development and how to utilize it to, for automation, that kind of stuff, it's just meant more, so that you can configure it and get some exposure to it, so that as we're learning throughout the rest of the course all the different services, you can also start experimenting with how to basically use those services through the CLI on your own, with some minor guidance from me. So that's why in this video, I'm just going to be touching briefly on just some things you can do. And we're not going to be doing anything too complicated. Just, pretty much stuff that we've done in the previous sections using the web console, but now we're going to be just doing it through the terminal instead. So let's start off with some very minor EC2 access. So we can, first of all, we can list, so let's just see that we have AWS CLI installed, and then let's see that we have it configured. Yep, we have it configured. And let's first interact with the EC2 service, right? So we can access it like this, AWS EC2, and we can use the describe instances command. Now, if you want to view like all the possible commands of a certain service on AWS CLI, there is some very thorough documentation here in the AWS CLI command reference docs.aws.amazon.com/CLI/latest/reference/EC2. And basically, if you replace EC2 with IAM, you get the IAM reference. If you replace it with S3, you get the S3 reference. So this will list out for you all the different possible commands that you can basically access or use with EC2 from the AWS CLI. So if you click on any one of them, you get a very detailed page, like a man page showing you all the different options and maybe some examples and so on and so forth. Okay, so this is very useful. Definitely use this to, this is basically all you need to really know, if you know how to use a particular service on AWS and you want to learn how to use it in the AWS CLI, you just come into here and you just look up the different functions. Okay, so this is for EC2, this is for IAM, and this is for S3. So let's go ahead and run this if you remember, I had invalidated my security credentials just so you guys don't end up using it. And that's why we no longer have access to our account, because our credentials don't work. So let me go ahead and refresh those credentials. We have our AWS reconfigured. So now that we have our AWS CLI configured again, we can go ahead and retry the AWS EC2 describe instances. And we get this huge JSON data file output that describes all of our instances. So we have instances, we have this instance here, which has the instance ID like so, instance type, key name, launch time, and then we can use a space bar to just print out the rest, the public IP address, public DNS name, and so on and so forth. Now we can use your network interface, you know, just a bunch of very useful stuff, groups, security groups, private IP address, owner ID, etc. Okay, so this is very useful, right? But it's just so much information, right? So we can actually, what we can do is we can hone in on certain sections. So let's say we want to view, okay, within reservations, we want to view instances, but we don't want to view all instances, we don't want to view everything to do with instances. Let's say we just want to view the instance ID. Okay, so we can add a query to our command, and we can say that within reservations, now this is case sensitive, so you have to watch out here. They're using capital letters for, you know, the first letter of each word. So reservations.instances dot, let's say the instance ID, right? And so what we're doing is we're getting all reservations, and then within all reservations we're getting all instances, and within all instances we're getting the instance type. Okay, and if we run this, there we go, we are just getting the instance type, right? Now what if we wanted to get owner ID instead, right? Owner ID is under instances, I think. Owner ID is under, I think it's within reservations. So we can go ahead and change this owner ID, and there we go, we're getting the owner ID, and so on and so forth. So you can specify specifically what you want. Because this is a JSON object, it's very easy to just traverse it and just find whatever you want. Okay, so this EC2 instance was created just for the sake of the section, right? So let's go ahead and terminate it. We no longer need it. We have the ID here, right? So let's go ahead and just terminate it. We can say AWS EC2 terminate instances, right? Before we're doing describe instances, now we're doing terminate instances. Instance IDs, we can specify more than one, but let's go ahead and specify just this one. So 03 F1 BC D915 A69 1B91. And we misspelled instances. And there we go. Terminating instance, current state, code 32, shutting down. That's instance ID. Previous state, it was running. Let's go ahead and describe our instances again. And, you know, it's, let's see. We should be able to see somewhere here, it's status. So it's still in use. Oh no, that's the private IP address. So I'm not sure. Okay, there we go. State, user initiated shutdown. So soon, once it's finished shutting down, we should not see this anymore. But it's essentially we have terminated the instance. So if you want to make sure of it, we can go back into the console the web console, pull up our instance, and we can see that it is terminated, right? So that's pretty cool. We did all of that through the CLI. So, that's just a quick example of how you can interact with EC2 using the AWS CLI. Let us now see what we can do with the with S3. So with S3, we can do quite a bit actually, right? So we've already seen that we can S3, we can list all the buckets, and we can even list within each bucket. So we can list the object. So number 1 AWS course website, right? And we can do quite a bit more as you saw in documentation. So we can make our own bucket. So AWS S3, we can make a bucket, and let's call it test bucket from AWS CLI. This bucket name is not available. Let's just add my name on to the end of it. There we go. Remember, it has to be universally available, the name. So now when we do AWS S3 list, we can see that we have a new bucket, test bucket from AWS CLI Smile. And now we can also try to see if there's anything within it, which we don't expect there to be, obviously, because we just made it, right? So test bucket from AWS CLI Smile. There is no bucket that had, Bucker should be a bucket, and there's nothing there. Okay, so we can delete this bucket, right? It's empty anyway. So AWS, we can use RB, which stands for remove bucket, and we can just go ahead and delete test bucket from AWS CLI Smile and AWS S3 LS. It has been deleted. Okay, and we can delete objects as well. So let's say AWS S3 LS test bucket from AWS. Oh, we deleted that, right? So number 1 AWS course, we have one object there, so we can go ahead and S3 remove S3 number 1 AWS course / puppy.jpg number 1 AWS. It's very important that you spell stuff correctly if you want it to work. And then now when we list it, there's nothing there, right? And then now we can, if we wanted to, we can delete this bucket as well. Now you can move objects as well. So there are a lot more commands, obviously, a whole list of them. So, S3 copy, oops, I didn't mean to press enter, move, remove bucket, make bucket, so many different things. Basically anything you can do with any file on your system. So that's a brief introduction to using Amazon S3 with AWS CLI. And finally, let's look at IAM. So we can create a group using create group, IAM create group. Group name would be, let's just call it my IAM group. And now we have this group created. It has this group ID, it has this ARN, create date, group name, etc. And then we can create a user, IAM create user, and the username, let's just call it my user. And now we have a user like so, and then we can add the user to a group. Add user to group, username, my user, group name would be my IAM group. And to verify that the my IAM group creates or the group contains the my user, we can use get group. So IAM get group name my IAM group, and we can see that we have these users, which is only my user within that group, and this is the group, right? And so that's a very quick introduction to how to use IAM with AWS CLI, and you know, this video should have given you a good understanding, a good idea as to how you can use the AWS CLI. Basically, any service, you know, will have a way to interact for you to interact with it using the CLI. And so you just have to look up the documentation. You know, I myself haven't memorized a lot of these commands just as I need to, right? I start using them, and then as I use them more often, they just start sticking with me. So yeah, I hope that this section really opened up your mind to the possibilities of what's, you know, what you can do with AWS. And it should, you know, just make you more excited about AWS, and, you know, just make you more enthusiastic to learn about, you know, to learn more about AWS, and hopefully help you pass your exams. This will be just a very quick section, and I will introduce you to a concept called instance metadata. And this is actually more to do with EC2 than anything else. I'm just going to show you how to access it through an EC2 instance. So instance metadata is data about your instance that you can use to configure or manage the running instance. Okay, it's divided into categories. So for example, host name, events, security groups. To view all the categories of instance metadata from within a running instance, you will use the following URI. So this is the URI here, 169.254.169.254/latest/metadata. Now, this IP address is a link local address and is only valid from the instance. So you can't put this into the browser and expect to see anything. You have to do this from within the instance itself. So let me just show you that very quickly. So I've created a new instance here since we terminated the last one. Let's connect to it. And essentially we can just curl that URI and we can see all the different categories. So we have IAM ID, instance ID, network, you know, security group, so on and so forth. So essentially, if there's a slash, it means there's more to it. And if it's not, you can just, if there isn't, you can just read it directly. So, you know, let's say that we wanted to go into instance ID. Okay. So then we just instance, how is it spelled? There's a dash ID. And we can see the instance ID right here. Okay. So we can access basically anything to do with the instance, any of the metadata. So if we just go into latest, you can see there's dynamic and there's metadata and there's user data. So user data is, remember, that was the code that we would specify when we're launching the instance, which would basically be like a sequence of commands that would be run when the instance is first launched. That would be to configure the instance for us, like to install anything we want to install and get everything configured before we start using it. So you can explore this, right? So like, you know, you can go into the metadata, into user data, and you can just see many different things. If we had a role attached to this, you'd be able to see it. You can see the network. Basically, you can access anything to do with the instance from here, all the metadata about the instance. And that's very useful when you want to start automating things and start writing scripts that just, you know, directly utilize some of this information. And so you don't have to do it by hand, right? So it would adapt to it. If the IP address changes, you just have this, you know, you just have this inside the script, and so it would just pull it in dynamically. And if any of this changes, the script would also change, so on and so forth. So that's just a very quick introduction to user EC2 metadata, instance metadata, not to be mixed with user data. Remember, user data was something else that we learned about. And yeah, so with that, let's conclude this section.